Excellent. So hi, good morning, everyone. My name is Arne Burns, and I will be kind of hosting and facilitating today's virtual session for the Illinois Environmental Health Association. So I'm going to go ahead and get us diving in, and I just want to introduce Christopher with EPA. He's going to talk to us today about hazards of lithium batteries. So Chris, I'm going to turn it over to you, and you can go ahead and dive us in.
Okay, sure thing. Can you confirm you see my screen?
Yes, I can see it.
All right, great. Thanks. Thanks for having me today. I'm Chris Newman with US EPA Region 5 in Chicago. I'm a solid waste management expert here in the region. Been with the agency for pretty close to 20 years now, working on used electronics, lithium batteries, as well as product stewardship and a few other topics. And can I just get a confirmation that you're able to hear me okay? Okay, great. So with that, let me just get my screens adjusted here so I can capture any cues that you might have from the video. And if you could just get my attention if there are any questions or anything, because I'm working on two different monitors. So, all right, moving on. So today I'm going to be talking about a few different things. I'm going to do a quick introduction about batteries, how they work, what kinds of batteries are out there. One of the questions that I got as I was preparing for this was there may be some interest about why we recycle batteries in general. And some batteries might be better to recycle than others. So I'll be covering that, talking about ways that batteries fail, a few fires that we've had here in Illinois, as well as one or two national cases. And then some information about EPA battery efforts that others can take a look at after the meeting. So first off, moving into batteries. Batteries, and it looks like particularly lithium batteries, lithium-ion rechargeable batteries are going to be our key to electrification as we move forward for transportation and even grid-connected storage for renewable energies. They're very powerful battery. They can hold a lot of charge compared to the other chemistries that are out there and are generally pretty robust. You can see here in the diagram how one of these batteries works. Like any battery, there's an anode, which is the negative terminal. There's the cathode, the positive terminal. You've got the electrolyte, which is the liquid inside of the cell. This, for those of you that are familiar with old-time lead acid batteries that you had to check the water level in or add acid to, that is the electrolyte. It's the liquid that the lithium ions move through to make the charge that we use for our load, be it a cell phone or a car or even part of the electric grid. What makes lithium-ion batteries unique compared to other types of batteries is this separator here. And this is a very thin polymer, a very thin piece of plastic that has very small holes in it. The holes are large enough for the lithium ion to move through, and it helps moderate the flow of lithium so that we get the desired performance that we want. Instead of everything traveling across at one time, it travels across slower than that so that we have remaining charge left for 20 minutes or half an hour later or something like that, just as an example. So that's kind of how the lithium battery is constructed. There are various types of different metals that are put on the anode. I believe it is, some of the nickel that you may hear about, the cobalt, the manganese, things that really make the magic of lithium batteries happen is then placed on top of the anode. So that's enough for batteries now. Should be able to get through the rest of the presentation with that little chemistry lesson. So there are two types of batteries in the world, which we're all familiar with. They're single-use batteries. These are called primary batteries. These are disposable alkaline cells. There may be some zinc batteries that you're familiar with as well. There are also lithium single-use batteries on the market too. So that's one type, that's primary. Those are single-use. And then there are secondary, and these are rechargeable batteries. This is generally, I think, a much larger group of batteries. The lithium-ion batteries are lithium-ion polymer batteries are secondary batteries, but also so is your lead acid or your nickel cadmium. And then there are varieties of different chemistries out there as well. There's vanadium flow batteries, things like that. Those are secondary batteries that are rechargeable. So that maybe some terminology that you see come up frequently. These batteries use a lot of different materials to work. And going back to your days of high school and college chemistry and electrochemistry, a lot of different metals can be used to make this charge flow. In the past, rechargeable batteries for consumer use, and still even today in some industrial uses, maybe nickel cadmium batteries. So we've got cadmium there, which is a RECRA metal, which is a hazardous heavy metal, but also lead is another metal. There's also some silver and mercury batteries that have been used over time, but particularly the mercury batteries, I don't think there are really many of those on the market. There may be some silver batteries and some very specialized uses, though. Other batteries, particularly some of these newer lithium-ion batteries, an example of this is in the auto sector, are using critical minerals. So you'll see nickel, cobalt, graphite, and lithium, all critical minerals inside of these batteries. And let me give you a quick definition of what a critical mineral is. Critical minerals are generally defined on a national basis by countries around the world based on their own country's situation. Here in the United States, critical minerals are defined by the United States Geological Survey, and they're minerals, kind of summing it up, that are very important for our industrial and consumer base. They may be minerals that we do have some supply of here in the United States, but much of the supply lays outside of the country. And it may be countries that we do not have very strong alliances with. So if that material supply were to be cut off, we would be in a pretty tight pinch because of that restriction in supply. So there are other materials, like if you're thinking about the alkaline batteries, those materials in there are affordable. Zinc, in particular, is a relatively inexpensive metal that is very commonly used in single-use alkaline batteries. So they're working to hit a performance and a price point. So they will use inexpensive metals and materials to be able to get the consumer the performance that they want. So that is our quick intro on batteries. Moving on here at EPA and generally across the federal government and industry, we are seeing a lot of interest in the circular economy and using materials that are in today's batteries as materials for the future generations of batteries. Once the material's been mined and processed into a form that can go into battery manufacturing, it is much easier to get that material back and recycled from a battery that's in use than to go through the entire supply chain. And that includes the amount of energy and the amount of waste in producing that battery material. So we're really taking a look and seeing how we can use current battery materials for future generations of batteries. And what you have on the graph on the screen right now is a graphic of where the expectations of battery use is expected to be by 2030. We're here at 2022, and boy, we have not seen anything yet. We're at about 400 gigawatt hours of use applications in 2022. We're looking at 2,000 gigawatt hours of battery use applications by 2030. And a lot of those batteries are going to be in the passenger electric vehicles that the automakers are working on developing right now. And they, just reading through the press in the last week or so, they have had some impacts of limitations on materials in their production plants. One of the manufacturers have been planning on 400,000 vehicles, EVs being produced, but they've had to cut that number because of limits in materials. So some very real world things coming together. So we're seeing a lot of interest in getting batteries recycled, and a lot of new technologies and new people coming into the marketplace. So again, back to that question of why should we recycle single-use batteries? That was posed to me when I started putting the session together. First off, landfill diversion is one thing. Maybe there's better use of those materials than putting them into a landfill. Some of the information indicates that the alkaline and single-use batteries are being used for, the zinc could be used for fertilizers. There's steel that can be recovered and a few other materials. So landfill diversion is one reason to take a look at recycling batteries. There's also some safety issues. Single-use and alkaline batteries, one of the more minor things may be leaking. It may damage a product. But also some of the batteries, particularly 9 volts, may have sparking issues because of the way that the terminals are laid out. It's easy for a piece of metal to get across the positive and negative terminal because they're right next to each other. So safety may be an issue for recycling batteries. But digging a little bit deeper into the life cycle analysis, sometimes the LCA is positive, sometimes it's negative. For those of you that may have worked with life cycle assessments, and life cycle assessments take a look at the environmental impacts of a product or service throughout the life cycle as the writer of the LCA defines it. So it may come from the gate of the factory and not include any of the material extraction activities and the impacts of those. Or it could go farther back and go to the point of where the materials are extracted and processed. So it can really vary. It depends on how that author sets it up. So sometimes we see that they're positive, and sometimes we see that those LCAs have negative impacts depending on how they're set up. So I did find 2 particular studies referring to LCAs. This is a table looking at global warming potentials from one study from the electrical industry. They found that the global warming potential of alkaline battery recycling is pretty high on this graph compared to what incineration or landfilling may be. They are taking a look at a pretty, we call it relatively crude recycling process compared to the next table I'm going to show you. Material may be shredded, it may be dissolved in acid, and then separated, and then materials going on to some secondary markets. So they show that the environmental impacts of either incineration or recycling are much lower than, incineration or landfilling are much lower than recycling. But there was another graph, another LCA done by someone in Jordan using data from the United States. And he saw that the carbon footprint for recycling was less than it was for the other options. If you take a look at disposal here, for example, this author, though, did a very different procedure. He took the time to literally take apart the battery and separate out the, one moment. Get rid of that. Sorry about that. To separate out the different materials by hand. So he separated out the zinc by hand, he separated the steel by hand. There's even some paper separators in there, which he also separated by hand so that he could, theoretically in the LCA drive those off to separate markets. He had a very different result because he used a very different process and procedure. Still, supports, has a valid way of doing it. You need to take a look at the results and say, how does this reflect where my batteries may go? So it's, it can really vary based on the process the author uses. When we take a look at rechargeable batteries and recycling, though, we've got to ask some different questions. Like I mentioned, these batteries will use toxic materials. There may be lead or nickel in them. There may be higher value materials. Lead or cadmium is the toxic materials. Nickel as a higher value material than zinc. We're seeing critical materials in them like cobalt or graphite. I just heard the other day that there's going to be a company in the US that's going to be starting getting involved in manufacturing graphite. So we're looking at different materials, different uses, and some of these may be safety hazards. I'll have a little video a little bit later on about lithium batteries and some safety situation that was created for this video. And you all have possibly seen some of the news, or even in your communities had some consumers that have had lithium battery fires in their homes or businesses. So there's a whole different set of conversations to go along with recycling these rechargeable batteries. There are also likely going to be some regulatory requirements as well, particularly when you take a look at lead acid batteries or nickel cadmium batteries. Those are, depending on the user, likely going to be universal waste if they're going to be not going to be recycled. So it's very key to broaden this conversation. But no matter what, battery recycling needs to be done safely so that we can get the materials back and also protect workers and the environment during those processes. One of the other interesting things that I saw as I was doing some prep for this, which I think is pretty insightful, is that one of the authors had noted that there is, to this point, not a consensus in the life cycle assessment field about how battery LCAs should be done. They don't all use the same starting and endpoints for the scope of the life cycle that they're looking at, how they take apart and account for the different materials, for example. So a variety of different things are out there based on how the author decides to set up their study. I did also want to pull up a graph here for electric batteries for the Nissan Leaf. You can see just dialing right into the recycling process, looking at two different recycling processes here, which isn't necessarily important for our conversation. You can see that there is a benefit by recycling in this case, because you're not having to go through those material extraction processes the same way that the production side might production analysis made based on materials that are extracted. And again, this is also taking a look at an electric vehicle, and you need to take a look and consider how the options may lay out compared to a traditionally fueled car with gasoline or diesel. So it's very good to consider the entire picture of an LCA and how that is going to be used. So I've mentioned a few times, a little bit more depth here on critical minerals. Really, these critical minerals are key to the magic of how particularly lithium ion batteries work. The cobalt, the manganese, and even the lithium working together in such a way that you can get a pretty good charge density compared to other battery chemistries. And as we take a look at power tools to cell phones, we all want these things to last longer. We want to get more distance out of our cars. We want our cars to perform better as we move into electrification. So we're taking a look at using these critical minerals. I've mentioned those before and how they're defined. One more addition was aluminum. That's also used as part of the metals that are used to construct the battery. And again, whoever's setting up that LCA may be making the decisions on how materials are recovered or recycled. And over here, we've got an image of some of the different battery chemistries, and you can see they're pretty varied. Lithium and cobalt and oxygen, manganese. Some contain iron phosphate. Some have aluminum oxide and cobalt. Some have tin with them. The manufacturers work with the chemistry to be able to get the performance, durability, and storage capacity that they feel their particular customer needs in the applications that they're envisioning. So it can really, really vary. In general, I think that someone that is working on a recycling program doesn't need to necessarily concern themselves with a lot of these details because ultimately the recycler will be sorting them as needed to work with their recovery process to be able to get back the materials that they're targeting. So one of the things I wanted to show was in this issue about lithium battery safety issues. lot of you probably saw this weekend in New York City, there was a fire with 38 people injured in an apartment building. New York City has had a spate of lithium battery fires this year. We had the fire chief from Morris, Illinois, at the Illinois County Solid Waste Association meeting last week, talking about this issue a little bit as well. In transportation, he was mainly talking about the fire in Morris back in 2021. What seems to be happening is that people are using micromobility devices like e-bikes or electric scooters. They are bringing them home to charge, and they charge them close to the door. Nobody wants to bring it inside the apartment any farther than they have to. Over time, batteries wear. Maybe they've replaced the battery. Maybe they've replaced the charger. It seems like some of these cases are attributed to mismatches between the charger and the battery. The charger does not stop charging once the battery reaches full charge because they're not designed for each other. And then we end up having a fire. Batteries overall, pretty safe. Failure rates I'm hearing are less than 1 in a million. Unfortunately, we hear about those cases. And when we take a look at high quality lithium ion batteries, we're looking at a failure rate of better than 1 in 10 million. So let me just show you this example here. Now, obviously, this is someone intentionally trying to start a fire. As soon as we get through the intro here, so we've got our battery smoking a little bit. He just punctured it with a pen. It swells, and the battery contains some flammable materials inside that as soon as it swells, starts jetting out. So it produces a pretty intense fire pretty quickly. And let me just show you that one more time.
Hi, Chris, hold on one second. We just have a quick question.
Yeah.
Was that fire demonstration in real time?
Yes.
Whoa. Okay.
Hi, Chris, I have a question.
Yeah.
Is that battery from any particular item or?
Let me move to the image. They don't. One moment. Let me get to a point where I can pause it. We can take a look. And let me get rid of the ads here. Oh, so it does not. I'm not going to be able to show what it is. There we go. It looks to me to be a laptop battery. Because it's got a very flat form. And it seems like there's a piece of plastic on the bottom, but it didn't say exactly what it was. So, so that is that is what can happen if a battery is pierced. In this case, it was intentionally broken. Generally, the battery cases are pretty protected. They're protected by the devices that they're in. The devices are designed to safely contain them. This is just an example to show the possibility, but battery fires do happen. Sometimes it's based on, it could be because of quality, could be because of the way that it's handled, or it could be a charging situation as well. So, one of the things that we are taking a look at here at EPA is we put in a funding proposal to take a look at the emissions from battery fires so that first responders and others can have better information about what they're dealing with, making sure that we're monitoring for the right chemicals in the air and even possibly deposition near the fire site that the community may need to be concerned about. So in the coming months, we'll find out if that proposal was funded, and we'll be able to get to work. So a little bit more digging deeper into how battery failures happen. There can be mechanical abuse. There can be deformation. Somebody is maybe battery gets too bent, the separator in between becomes damaged, and then you get more and more lithium moving across from one side to the other. You get heating created, and then you start getting swelling of the battery, and it becomes more fragile and subject to damage. Swollen batteries can be contained by the pouches or the cells that they're in. But again, in that case where it was intentionally breached, you saw what could happen. There may be some torn separators in there. That's another physical part of the battery where it electrically connects. And we're seeing some of these mechanical abuse situations happen in recycling facilities and in the waste management stream. These recycling facilities are they require a lot of mechanical equipment, conveyors, for example, certain types of sorters that may create a fall. And the batteries are just not designed, or if a battery is damaged, there may be more damage added to it during that recycling line. But that's not to say that some batteries don't make it through. Other batteries can make it through the recycling facility with no problems, but it is becoming a big challenge for the waste industry. So it's another reason why we encourage people to do the right thing and get these batteries recycled so that we keep them out of our waste stream. There may also be some electrical abuse going on in some of these damaged cells. It could come from a manufacturing defect or something like that, or just the charger issue that I mentioned of overcharging or external short circuits. This dendrite growth is dendrites are very small metal hairs that will grow out of certain metals. Batteries are affected by it. That dendrite will, over time, pierce the separator, just slowly allowing a little bit more lithium across, creating a little bit more heat and a little bit more heat, ultimately damaging the battery. And then we've also got the possibility of overheating. They are subject to temperature, or that battery gets too hot and the separator just falls apart, allowing the the lithium to all rush to one side, creating more heating and more damage. So just want to highlight quickly a few battery fires. These are ones that have gotten our attention here at the agency. Here in our office, people have responded from Ieha Region 5 and items that caught our attention as we put together our proposal to take a look at the emissions and smoke from these battery fires. So the first one is Morris, Illinois. This is June of 2021. There's an old paper mill in town that someone had moved into unbeknownst to the community and the municipality and was storing batteries there for a project I think that they were working on, and had accumulated close to 200,000 pounds of lithium batteries. Somehow the report is not out yet, but somehow those batteries caught fire. And what you see here is the entire building engulfed in smoke. The County Emergency Management Agency ordered a half-mile evacuation. As it would go, the site was surrounded on three sides by residential properties. So, really in a thick residential area there that, people had concerns and needed to be evacuated to prevent their exposure to this material, to the smoke from this. And it's my understanding that they were out of their homes for probably 2 to 3 days. Eventually, they put the site out using concrete to help thermally isolate the batteries from each other, or pallets of batteries from each other, because it wasn't necessarily the flame that was causing other batteries to become on fire, but it was the heat that was generated. So they were able to isolate thermally different pallets or groups of batteries that were in the site by using Portland cement that they'd pumped on. EPA provided sampling through our Superfund program for air monitoring, so that first responders had a good idea of what was coming out of the fire and how to advise the community. Then post-fire, US EPA was involved with the removal of all the batteries from the site, getting the inside of the site cleaned up to the point where it was there were no concerns about safety for entering it because of ash or fire debris, and has turned it over either to the owner or the local community for further work. So that site just wrapped up within the last 6 weeks or so. The last of the batteries were shipped off to recyclers in 2 or 3 spots around the country, and one of those spots was in Canada. So that was a big one that caught the news. More recently, in August of 2022, there was a fire in Madison, Illinois. This was a battery and electronics recycler that caught fire. The community there, again, this site was surrounded by by residential properties on 3 sides. They in that community put in a 1.5 mile shelter in place for a day or two, I believe, while the fire was being struck. It did take a little while to make sure that it was fully struck, because batteries would heat, and hot spots would be created after the main structure fire was put out. So it took some vigilance on that one. And again, US EPA provided air monitoring support for that. And finally, I want to mention, not finally, I've got one more after this, sorry. I want to mention the Houston Railroad battery explosion. You may not have someone that's a battery recycler in your community. You may not have an electronics recycler, but batteries may be passing through your community. This was back in April of 2017 down in Houston, Texas. An electronics recycler was shipping lithium-ion batteries, excuse me, in a 55-gallon drum. I do want to mention that the batteries were not properly packaged. The U.S. Department of Transportation's Pipeline and Hazardous Materials Shipping Administration is doing a tremendous amount of outreach across the country to make sure that batteries are properly packed and shipped. So hopefully we don't see this situation again. But these batteries were not properly packed or shipped. They were in a drum. One battery, maybe several batteries, started heating, creating pressure inside the drum. Finally, the drum could not hold that pressure, created an explosion, which you can see tore apart the shipping container that it was being shipped in. The blast blew out windows nearby. There's another story of a resident that lives alongside of the rail yard that this container was in at that point. Fortunately, it was in a rail yard and they were able to move it on to a siding to get the fire struck. He was thrown to the ground, and I guess up against the side of his home as well. There was some damage to the rail car that it was in, and I believe the rail car below it as well. This fire took about 2 hours to get struck. And you can see here, some images of the container, but also the materials that were being shipped were not properly packaged, and just an idea of the amount of smoke that was generated. So again, I want to mention the DOT hazmat shipping requirements weren't followed, and this is one of the good examples of why it's important to follow those requirements so that we are able to have safer shipping infrastructure for communities and for the shippers. Then finally, the Shoreway Material Recovery Facility. This was out in California, a recycling site that had fires in 2015 and 2017. At one point, the community was doing a battery recycling program where they would tell the resident to put their batteries inside of a plastic bag on top of the recycling bin. And then the driver would pick up that bag and put it inside of a container and collect the recyclables and move on. But batteries were making it into the recycling bin still, causing fires. At one point at the 2017 fire, the facility was pretty much totally consumed and a total loss. It was their second fire, multiple hours to put the fire out, and it took about 80. The responses for these facilities can be humongous. It took about 80 firefighters to get that fire struck. Fortunately, there were no injuries, but it did take months to get the facility online again. A lot of job loss, and there are layoffs, and there was a challenge, a big hole in the community's collection and recycling infrastructure. One of the other side effects of this fire and the subsequent fires that the industry has had is tremendous. Insurance rates in the recycling industry have gone up tremendously, and the waste management industry. Previously, insurers weren't paying a lot of attention. They didn't see a lot of risk, but these batteries really caused them to take a look, and many insurers have left the market, and those that remain have increased their rates. To the point, it's my understanding with this facility that the insurers did pay out for the fire to get the facility rebuilt. Once it was rebuilt and they went to go get insurance, the risk needed to be spread among multiple insurers to have sufficient coverage. And if the facility were to have another catastrophic fire again, like they had had that caused it to be rebuilt, they would probably have to become self-insured. So it has become a real challenge for the waste industry. So just a few wrap-up comments on that. Batteries can be anywhere. They can move through your community or be recyclers in your community or businesses. It can be a real challenge to get these fires out. So first responders need to be knowledgeable and prepared about facilities. So real quickly, so we're kind of getting a little tight on time here. EPA has been charged by Congress to take a look and develop information on battery collection best practices so that individuals and businesses know how to collect batteries, where batteries need to go, so that we can recover these materials, but also reduce the hazards from improper disposal. We'll be looking at things that are technically and economically feasible and safe and beneficial to getting these recovered critical minerals recovered. We also have a battery labeling guideline going on, initiative going on, taking a look at labeling. You can see this battery here. What does no trash can mean here in the United States? This is a European Union mark. Other batteries may have the trash can and the chasing arrows. What does that mean? Maybe that means it doesn't go in my trash can, but it goes in my recycling bins because it says recycled. So we need to work on communication on batteries and on products to get these materials safely managed. So what should be happening with these batteries? Lithium-ion devices and the batteries inside of them should be sent to certified electronics recyclers, retailers and recyclers that are participating in electronics take back, or your local solid waste or HHW collection facilities if they're sponsoring battery take back. Lithium-ion batteries that are separated can, or easily separated, like power tools, versus a phone, which is very well attached, can go to recycling locations, which Earth 911 may have. And Call to Recycle is also a great program that runs a nationwide collection event and has a lot of safety information and training for people receiving those batteries. So that's Call to Recycle and earth911both.org. And make sure when you're handling these batteries at end of life, make sure that they are placed in bags, or the device is placed in a separate bag. Use non-conductive tape like the electrical tape, or that's a good example. If the battery becomes damaged, contact the battery device manufacturer for specific handling information. And I just want to mention here, if you've got your camera handy, this QR code gets you to EPA's used lithium-ion battery webpage. We've done a few webinars over the years that you can get to from our Sustainable Materials Management Web Academy page. If you search on batteries, you can find battery webinars that we've done with the Department of Transportation, webinars with electronics recyclers on management challenges, and an introduction to lithium batteries overall. A few other resources, you can find those webinars that I mentioned by using this top QR code or the link. And then we have an email list that doesn't have too much traffic on it, so it shouldn't fill up your mailbox for information on our circular economy updates. So with that, you've got my contact info if anything else comes up. And if we have any questions or anything, sorry for going over there.
No, that's okay. Thank you so much. Does anyone have any questions, or anyone in the room have questions for him before
Hi.
we started? Oh,
Hi, Chris. Yes, I have a question. I know this might be a duh question, but what is used to put out the fire? Is it foam, water, or both?
So it depends on the situation, and there are a few materials out there. There's one called cell block, which is used for small device fires. So if you were to have a cell phone or a few batteries that caught fire. This is a glass bead that's foamed that you would put on top of the battery to basically the glass melts and separates it from the air, smothering the fire. That's a commercial product that's available. When you move into some of these larger structure fires, my understanding is they're using water as one way to keep things cool, but also to fight the structure fire. And then in Morris, they did use Portland cement and got innovative as a way to keep the heat from transferring from battery to battery or pile of battery to pile of battery. So it can be a challenge.
And then there's a question in the audience here. Go ahead.
So, Chris, right now, lead from batteries, particularly from vehicle batteries, the recycle rate for lead is the highest of all the metals. Because of mandatory recycling in Illinois, and I presume otherwise, because lead is such a dangerous material, are we going to be able to use that same mechanism for mandatory recycling of EV batteries?
So I would say that the story isn't written on this yet. Manufacturers are involved. The auto manufacturers are involved in getting batteries back. And generally, that's a pretty tight system as long as your vehicle makes it back to the dealership. There have been some questions about junkyards and how they're dealing with batteries. There have also been some of these batteries show up at some of the events that I mentioned in my presentation. So hopefully we'll see. And they do have an interest in getting these materials back. So that's still being worked on, but I think it is a model. It's a model that I've heard discussed. So.
All right, well, thank you. Thank you so much. For anyone else who has any additional questions, please reach out the contact information here, but I'm going to go ahead and get us moving on to our next speaker for today. Again, thank you, Chris, so much. We really do appreciate it.
Thank you.
So for our next speaker, I have Simone, and please correct me if I'm not saying your name correctly. Also joining us from EPA, and they'll be talking about water sampling. So I'm going to turn it straight over to you, Simone. Thank you.
Thank you so much. And good morning, everybody. Give me a moment here to share my screen, and hopefully that works out well. I'm going to start my slideshow. So we're changing gear here a little bit. I'm coming to discuss with you drinking water sampling for protecting human health. And this is kind of work that we're very passionate about at EPA's Office of Research and Development, or else ORD. We're headquartered in Cincinnati, Ohio, and we have a lot of engineers and scientists working on drinking water matters for a very long time. We did collaborate with colleagues from health officials from the Association of State and Territorial Health Officials specifically, or else ASTHO, to come up with a report that I will also be talking about today. But please keep in mind for my presentation that kind of my angle here is mostly from the research point of view, because I'm a research engineer at EPA's ORD, and also from kind of the drinking water industry's perspective. It is kind of an honor and a great opportunity to be able to reach out to health agencies and health officials today. So with that, I'm sure you've all read the news and are pretty familiarized with kind of high profile cases where elevated lead in drinking water was linked to elevated lead in children's blood. This is just one example journal article by Dr. Mona Hanna-Tisha, kind of describing the Flint drinking water crisis. But a long time before that, we did have elevated blood lead in young children due to lead contaminated drinking water in Washington, D.C. during what was then called the Washington, D.C. lead in water crisis. So we know that elevated lead in water can be associated with elevated lead in children's blood. And we're trying to figure out ways to control that situation. It was really interesting to me when, as a tourist, I went around, areas close to Cincinnati where we're headquartered, and I ran into this historic site in Dayton in Ohio where it was basically the residence of an American poet. We could go into all the rooms of the house, and the kitchen was really fully plumbed with lead pipes. So that was kind of interesting for me to see, especially considering my research focus, which is on lead. And we really do have legacy lead plumbing sources around the whole of the United States. They may look something like this if you haven't had the chance to look at a lead pipe. On the top left here, you see a full lead service line on the ground. In the middle, you see a partial lead service line. So what's happening here is you have kind of the thicker lead pipe portion on the right, connected through a white lead solder joint to a new copper pipe on the left side. So the copper pipe is the more shiny, kind of reddish color. And on the top right, you can see a lead lined iron service. So this is an iron service line, which we cut open so that you could see the lead lining inside of it, which is really what's coming into contact with flowing water. And lead lined iron services were historically used in some parts of the Northeast and even the Midwest. On the bottom left, you see a lead gooseneck that was a much shorter lead pipe segment that was used to connect water mains to home plumbing in the past. And on the bottom right, you can see a galvanized pipe, which has also been associated with lead release into drinking water through a few different mechanisms. So we have all of these materials still in service. And the concern with them is that the pipe scale that has formed in them can actually be a big source of lead. This is what this graph is showing here on the left, where you can see kind of highlighted, contained within the red rectangle here, all the different kinds of scales that our lab has observed on harvested and excavated lead pipes that we've collected. And all of these lead minerals, all these lead scales have a really high percentage of lead by weight, which is shown on the x-axis here, much higher, for example, than the lead paint standard or the lead soil standard. So pipe scale particles do have more lead than paint, soil, or even hazardous waste. And the concern here is if any of those small particles get released due to hydraulic disturbances or chemical changes in the water, that may result in really important exposures to lead from drinking water, sometimes potentially more than paint or soil. So how we we often describe it when we talk about this is you kind of can imagine it as drinking through lead painted straws. And this is really important because water is a product intended for human consumption. So, you know, we're all exposed to this potential lead source if there's legacy lead plumbing still around. And aside from the lead pipes, we also have other lead plumbing sources. Look at the leaded solder joint on the left here. This was actually from a photo that we took from the home of a lead poisoned child in North Carolina, where the leaded solder is really this grayish material on the outside surface of the copper pipe, but it also had sipped on the interior surface, and this is exactly what caused, in that specific case, the elevated blood lead. In the middle here, you can see a leaded brass faucet model. So these are chrome faucets. If you kind of open them apart, they contain a lot of different components that do come into contact with drinking water. And some of those components in the past, before the ban on lead, contained certain percentages of lead in the brass alloy. And on the right here, you can see leaded brass valves. Again, you know, valves are different kinds of fittings used in plumbing. You might also see water meters that might contain lead and a bunch of other fittings as well. So these are just some illustrative examples here. So what's important to recognize is that lead sources, you know, in drinking water plumbing are not uniformly distributed. And this is just one schematic of how plumbing might be in one home, where, for example, you can see the water main here in the bottom left, which might be connected to the service line through a lead gooseneck. And I showed you a photo of that previously. Or you might have a lead service line connecting the water main to the home plumbing. And then once you start looking at the home plumbing, you have these little kind of point sources of lead, these really small kind of brown components. They might be brasses, for example, in valves or in water meters. You might also have leaded solder joints. Those are the T's you can see in the cold water line here. You also see kind of this brown colored faucets and shower heads and things like that, which might also, in some cases, contain lead. And imagine how many different configurations there are, how many different ages of homes there are and how many different preferences. So just to get an idea of how different lead sources might be from city to city, from, even within the same neighborhood and homes that are next to each other. So we kind of start thinking about this then in terms of how we sample drinking water to assess lead exposure and what would constitute a representative water sample, considering that there's all these factors affecting lead release that contribute to lead variability. Because if lead in water was kind of a fixed concentration, then we could collect any kind of water sample and it would give us, the true extent of the problem. But considering all these factors affecting lead release, such as the fact that you might have different lead plumbing materials, different dimensions, different configurations, and age, you might have different water chemistries or else corrosivities to lead in different communities, different hydraulics and hydraulic changes, even individual water use patterns actually affect the pathway of water through a home. For example, how much water might stand within a lead service line before it moves then to be captured, in our next glass of water at the kitchen tap. So all of these factors contribute to lead variability, spatial variability, temporal variability, and variability in the form of the lead. Particularly dissolved versus particulate lead is what we typically worry about, which really poses the question, how can we sample water in the way that truly reflects water that residents consume? We looked around to realize that there's really a lot of different sampling protocols out there within the United States, in Europe, and many other countries. And there isn't a single way to do it, to sample for lead in drinking water that exists. Because there are so many different protocols and because each has a specific use answering specific question, we came up with the idea of categorizing the types of questions that we might have to be able to figure out, to customize a sampling protocol to meet, the need or to be able to answer that question. So, for example, we came up with these 3 general categories. If the question is whether a water quality meets a regulatory standard for lead, so these are drinking water, regulatory requirements in the United States, then you would sample for lead regulatory compliance. But if the question is where exactly is the lead coming from or what type of lead is present, then a different kind of sampling protocol might be needed, what we call lead plumbing sources determination or lead type identification. And perhaps the most important question, and probably more relevant to you as an audience, is the lead exposure assessment type of sampling. What is exposure of the general public to lead in water in a specific neighborhood or residence or town? So I like to go through this because these are EPA regulations, and it's kind of good to explain the framework for them. When we're talking about the lead and copper rule, which is under the Safe Drinking Water Act, and it is the regulation drinking water utilities need to comply with in the United States, the lead and copper rule is a very specific type of framework. Basically, let's say you have a big city. The LCR requires that drinking water utilities identify a sampling pool. That's a certain number of homes believed to contain major lead plumbing sources. Sample those homes with a very specific protocol, which is collecting 1 liter of water from the kitchen tap after overnight stagnation of more than 6 hours, and then gathering all the results from all the different homes sampled from the LCR sampling pool to calculate a 90th percentile lead concentration among all of those homes, which is then compared to a lead action level of 15 micrograms per liter. It's kind of important to recognize that the 15 micrograms per liter lead standard in the LCR is not really a health-based value. It was set as a concentration considered feasible to achieve, and it's more so a trigger for corrosion control treatment system-wide rather than an exposure level for an individual home or residence. So the whole thought process behind this rule was to identify system-wide problems with corrosion control rather than problems at individual buildings. And if you look at the pie chart on the bottom right here, even in a city that does meet the LCR action level of 15 micrograms per liter, what this means is that the 90th percentile, 90% of the homes sampled under the LCR have a lead level less than 15 parts per billion or 15 micrograms per liter, but 10% can actually have a lead level higher than that. And remember, the 15 is not even a health-based value. So it's kind of important to recognize that. And if we really wanted to know lead plumbing sources in a residence, which is a very different question than system-wide corrosion control optimization, we might need to do different kinds of sampling. I'm in favor of sequential sampling or else profile sampling. It's a bit more involved, but it gives way more information. And you can kind of see it here in the schematic. Basically, if you have the kitchen tap, you collect a sequence of samples, so not just one, like we would do for LCR compliance, for lead regulatory compliance with the drinking water standard. But here you collect a sequence of samples from the kitchen faucet. And the idea is all of this water then reflects water throughout the plumbing line all the way to the water main. So if you have a service line, and that's kind of circled here, then there will be some of the samples collected will reflect the service line. And they can give you a good idea if your service line is made out of lead, or even if your chrome-plated brass faucet might have leaded components, if there's leaded solder joints somewhere along the plumbing line. This type of sampling is very helpful to help you identify all of these sources. And of course, if you think about kitchen faucets or water meters or valves, these are really small components. So taking smaller volumes of water can better capture and isolate those sources of lead than taking, for example, a 1 liter water sample to capture a long lead service line, which holds a much greater volume within it than a water faucet. So this is what a profile looks like. If you conduct this type of sampling, you can then quantify total lead, and that's what's shown here on the y-axis versus the sequential volume of water collected. And you can kind of map your plumbing line. In this specific example, you can see that this residence had a really long lead service line reflected by higher lead concentrations, starting really at the 4th, 5th liter of water that had been sampled and on. And this is what we call diagnostic sampling. And it really allows for identification of lead plumbing sources, not just lead service lines, but also lead goosenecks. This is not an example of a lead gooseneck here, but it can be used in a similar way, or leaded solder joints, brass faucets, valves, and other plumbing fittings. And when we're talking about exposure assessment, which is, again, a different kind of question here, what we're trying to think about is how can we best mimic how consumers use water? And the approach here is what's called composite or else cumulative sampling, where the resident, for example, might collect water each time they turn on their faucet to consume water. And there's different kinds to do this type of sampling. They may be automatic or manual. And in the automatic composite approach, this is kind of shown at the bottom here. On the left, you see a schematic of it, where basically you can just have a plastic container, just a device affixed to the tap and operated by the consumer. So each time the consumer turns on the faucet to consume water, either for drinking or cooking, they can also turn on this device, and a certain percentage of every draw they meant to use for consumption, they route into a collection vessel. And slowly this adds up. You get a cumulative water sample, which really better reflects the resident's water use patterns, and then you analyze that for lead. And because this is a little bit complicated, we came up with a simpler way to do it, which is what we called manual composite sampling. Just have one large HDP sample bottle like the one shown here, and every time water is used, ask the consumer, the resident, to pour a small volume into this collecting vessel to incrementally fill it up. Let's say after a day of water use, a few days, or even a week. For example, in the morning, if the resident uses water for coffee, then you start with that little increment here in the blue at the bottom of the bottle. And then as the day goes by, you add on water, let's say when water is used for preparing breakfast or when the resident drinks a glass of water later in the day. So this is, again, what we call composite sampling, specifically for exposure assessment. So kind of the question, I also have for all of you is, in environmental assessments of lead poisoned or lead exposed, children with elevated lead, whatever that definition is for you by health departments, is drinking water tested? And if yes, what's the sampling protocol and what can the sampling protocol tell us? So we kind of wanted to go into this. We collaborated with ASTO, as I mentioned early on in this presentation, and ASTO published this report titled Going Beyond Regulatory Compliance for Lead Testing in Drinking Water, which I encourage everybody to take a look at. It's open to everyone and the link is offered below. But basically, we collaborated with ASTO to discuss all of these different types of sampling and to describe the differences among the sampling types, and considerations for adding other kinds of sampling, not the default LCR regulatory compliance sampling, to meet other objectives other than LCR regulatory compliance. ASTO also conducted a survey summarizing results from 14 jurisdictions about their environmental assessments and any requirements they might have for testing drinking water sources and how they do it. So I think that's a great kind of informative report to go over. These are some highlights from the ASTO report and kind of some of the conclusions of the report, where ASTO recommends that state and territorial health officials consider other types of sampling protocols for exposure assessments, and that they work closely with drinking water primacy agencies, public water systems, and the public to kind of help control drinking water as an exposure pathway for lead. But perhaps most importantly, and that's, I think, one of the last statements in the report, is that in all cases, answering the question, is my water safe, which, by the way, I get a lot and my colleagues get a lot in our office at the EPA, should be qualified by an explanation of the specific water sampling protocol that was used and the information it can or cannot provide with respect to lead exposure specifically. So to summarize, elevated lead in blood can still contribute or even cause elevated lead in TAP can cause elevated lead in children's blood in those cases where there's suboptimal corrosion control and still legacy leaded plumbing present. And if we sample tap water at home, schools, or other buildings, we can get an assessment, of lead through water consumption. Because lead in tap water can be so variable, both spatially and temporally, different sampling water protocols will then yield different lead concentrations. So it's important to recognize what regulatory compliance sampling under the lead and copper rule does and does not. For example, regulatory compliance sampling does not diagnose lead plumbing sources like diagnostic sampling would, that sequential profile sampling that I mentioned. And regulatory compliance sampling under the LCR does not assess lead exposure like exposure sampling would. For example, that composite sample where you incrementally fill it up each time the resident uses water. It came from the ASTO survey that many health departments do not sample drinking water during environmental assessments. And certainly the cost of being able to do that, the logistics, the timelines are all considerations. There's very limited resources for us to draw on to do, what could be done. But it is possible for individuals to be exposed to elevated water lead, even if in that community, the drinking water utility meets the federal lead and copper rule water requirements. So it's kind of important to recognize that. Also important is to understand the differences between water sampling protocols for lead in water. And even if it's not possible to conduct, appropriate sampling, to then be cautious how to answer the question, is my water safe, by qualifying the answer with an explanation of whether water was sampled at all, and if it was sampled, what type of protocol was used, and what sort of information it can or cannot give us. We've been thinking about this question for a very long time. In my office, as I mentioned, we get that question a lot. So with that, these are the two resources that I recommend for anyone interested digging further into this. The ASTO report that I mentioned previously, and a paper that colleagues at EPA's Office of Research and Development wrote in 2021, which is open access. So it's anybody can access it. You don't need a subscription to this specific journal. You just click on the link and can download it if you're interested. Just acknowledging some of the other co-authors of that paper here. And with that, thank you very much. And here's my contact information.
Okay, thank you so much, Simone. It was excellent. Did anybody have questions, or even from the audience in here? Did you guys have any questions for Simone before we move on? Let me make sure there's nothing in the chat.
Hi, Simone. Cheryl Walls, Cook County Department of Public Health, the lead program. The question of the Flint, Michigan children. I understand that there was no baseline lead levels for the majority of the children, or maybe even all the children. How do they know these children's lead levels went up caused by the water, or if it wasn't from their environment being paint and possibly other sources of lead? That's my question.
Hi, Cheryl. That's a great question. So we didn't really go over that paper that I mentioned just in one slide, which was Dr. Monahan Atisha's on Flint specifically. But my understanding is that, and Dr. Monahan Atisha is a pediatrician with access to children's information, you know, and blood lead and all of that. My understanding is that a comparison was made between the percent of children exceeding certain blood lead thresholds before a water source change was made in Flint, Michigan, and after. So in two different time periods, and that there was information before to be compared to what happened after, and that there was an increase in the percent of children with elevated blood lead, and that was kind of shown in that paper over there that is in one of the slides. Thank you for the question.
Were there any other questions that we had? Okay, if there's nothing else, I just want to say thank you again, Simone, so much. Greatly appreciated. And then I believe Curtis is online. Okay, yes, I see you, Curtis. Awesome. So we'll go ahead and move on to our next presentation, which is Curtis from Infiltrator, and he'll be talking to us about enviroseptic basics. So Curtis, if you're there, I'll go ahead and allow you to share your screen and you should be good to go.
Great. Good morning, everybody. Thanks for having me. Let's see. I was going to try to turn my camera on just for a minute, but I might leave it blank anyway. So anyway, I'm going to talk to you a little bit about advanced enviroseptic. Let me share the screen here. Can everybody see that?
No, we don't see anything.
Okay, here we go. Okay, has my screen popped up there by any chance?
It's popped up, but it's all black.
It's all black.
It just says Curtis has started screen sharing. Ah, there we go. Awesome.
Hey, I'm not the most technically advanced people here. So just so you
No,
know.
it's okay.
Is it still
No, it
sharing?
just went away.
I'll get it here in a minute. How about now?
Yep.
Okay, great. Hey, we're getting somewhere.
This looks like it just says click to add title, click to add subtitle. I think this is a different presentation.
Okay, my presentation's up on my screen now. Can anybody else see that or no?
No.
Try to share.
Let me see. Might need to.
It says I'm sharing my screen.
Okay.
Yeah.
Yes, yes.
All right, hey, we got it going
Awesome.
on. So thanks, Cheryl. I saw your head nodding there, actually. So thank you very much. So anyway, hey, again, I'm Curtis Clucky with Infiltrator. I'm really sorry that I actually am not able to make this conference. I wanted to actually be there in person this year, but I was one day away from getting it changed over. So for those of you that kind of saw some of this in March, I apologize, but we will throw in a couple little wrinkles into this as well. But anyway, this is made strictly for the Illinois market. Let me see here. Okay, so today's topic, we're just going to talk about advanced enviroseptic and just do a quick introduction of the material. It's a completely passive, non-mechanical product that we use for septic and sewer. I guess I should back up here for those of you that don't exactly know. This is a non-mechanical treatment process septic lateral field. We call it CTD. It's actually combined treatment and dispersal. So it takes the place of a lot of the mechanical treatment units that are out there, some of the drain field type applications that are out there as well. So just to kind of give you a little bit of a snapshot of what it is. But again, it's a superior treatment results. It actually meets the NSF standard 40 that most treatment units actually go through in testing. So we're fine on that. It treats and disperses in exactly the same footprint. So that's the combined treatment and the dispersal process of it both. Typically, it's in a much smaller footprint than most of the other products that we handle. And we, just full disclosure, we handle drain fields, we handle expanded polystyrene chambers, we handle advanced treatment systems. So we're pretty diverse in all of the different products that we've got. So anyway, we can speak on a little bit of all of this, but the Presby Advanced Enviroseptic is literally just a 12-inch outside diameter piping that has a bioaccelerator mat on the bottom of the material. And God dang it, I just screwed that up. I don't know how to get out of this. Could you? Has my screen changed on your end?
Yeah, I think you might need to maybe restart the slideshow again and
Let's do
then,
it this way. Nope, I found
yeah,
it. I clicked the
there we
wrong
go.
button. So all right, hey, we're gonna get through this, I promise. So anyway, so this pipe has what we call skimmer tabs inside. There's a green coarse fiber in it with ridges, and then it's just strictly a corrugated pipe. So what you're seeing here is that the air void space at the top of this pipe where it says right in the center, this is what I meant to do actually was this. So we've got an air void space here. And your sewage is going to actually flow in here through the bottom, and there's an accelerator that actually pushes us down through the system itself. So here is a actual kind of product disclaimer and look of what it is of what you just saw from an end view. So you've got your 4-inch pipe, your bioaccelerator here, and then a randomized fiber. We call it Easter grass. I'm not supposed to do that anymore, but that's what we call it so that everyone knows what it is. And then it's wrapped in a geotextile fabric. So it gives you a tremendously large area, surface area per foot of pipe in the product itself. D boxes and flow equalizers. So we always use a D box when you're dividing flow or pumping to this system. If you are strictly just doing a gravity flow system, you do not have to have a distribution box to work this product if you're doing it in a serial application. We'll get into that a little bit. What you see on the right here is the flow equalizers. It does not matter really what type of D-box, whether it's plastic, concrete, if you put it on a pad, if you don't put it on a pad, if you put stone underneath it, that D-box is going to at some point get out of level a little bit. So these flow equalizers are put on the inside of this distribution box here that you can dial up the flow to make sure everything kind of gets back to level again when needed. This product always goes in with system sand, and it's typically known as concrete sand. In the state of Illinois, it is commonly referred to FA1 and FA2 as the sand requirement. Every state in the country has a different road and bridges comment to the sand. So if you come up to the top of this, and if you have a question if it's the correct one, the ASTM C33 spec is what we're always specking out, even though it might be something, called something else on your end. This product is always put into sand, and it's always installed in beds. So this is not a trench replacement type product. This is strictly going to be a sand-based unit. Where we talked about earlier, if you can follow my cursor here, is where the treatment would happen, where the pipe is actually installed in the sand. And then these 6-inch sand wings off to the sides are actually what the dispersal method would be for that effluent to leave the treatment process and go out into the sand and into your soil types. So very, very small footprint. You can see on the side here, this is always going to be a minimum of 6 inches of sand from the bottom of our product. And then from here, it is a 12-inch vertical separation to your limiting layer, whether it's bedrock, high water tables, things of that nature. So we do get some other great attributes with this product, a lot like the treatment processes are that we have out there. So we've got a ton of different diverse bed layouts where you can put these on sloping sites versus level beds. You can curve them. You can do a combination of all these layouts, and we'll run through a couple of these here. So the top one would be your typical pipe and stone bed, or your lateral trenches that you would do. And being able to put our product on a slope here, as you can see, really takes care and saves a lot of soil and your original grade of material. So you're not having to dig and bring a bunch of soil in on top. It's a true huge space factor savings in these systems that are out in the field, compared to even the stone and pipe or the chamber systems, which get a pretty large reduction in the state. Even at 5 foot center to center, a lot of times we're able to get these onto a much smaller footprint in the field. And that the 12-inch vertical separation credit is really enormous for this stuff, especially in the state of Illinois. Once you get south of pretty much Bloomington, everything's a pretty high water table. Curved beds, just showing that the pipe is very flexible, and the way that you can put this product in the ground is extremely flexible in the field. So you could follow a contour of a driveway if that's all that you were able to do it. Sloping and curved beds. So the AES rows are sloping and curved to match this terrain. A lot of times you won't really even know that this product is in the ground, with the exception of the candy cane vents that we would have in these on the installation side. And obviously, if you're the homeowner or the installer, you would know that the product was there. I'm going to show you some of this stuff later on as we get through the presentation. So, oops, let's go back. So layout configurations. In basic serial systems, as you can see, you can come in straight from the septic tank right into our first row. And as you see, this will snake through like a serpentine system here. And at the back end of this, you would have a 3 or 4 foot tall candy cane vent. In these basic serial system applications that you do that are less than 600 gallons a day, you would not have to use a D-box. You could actually pipe straight from the septic tank right into this first row. And then we'll talk a little bit about these extensions on the back end of these basic serial systems as we go. Here is just a kind of depiction of one, and you'll see a whole bunch of stakes in here. So these folks will come into the front end here and just kind of snake through this whole entire system. And at the back end, you would have an actual candy cane vent like we had talked. All these stakes in here are basically staking that product in place for the installer to actually lay the sand in there so that the pipes don't jump all around, and you move around and you move your spacing. So we have to have 6 inches of sand in between all of these pipes here. So it makes for an extremely easy way to do the install. Once they get the system sand in here, then they can pull these stakes out. What you see on the left here is the actual system sand extension, which is just a 6-inch deep sand extension that actually is what you would use to do the disposal portion of this. Combination layout, 600 gallon a day or greater. You would come into like a distribution box and you would divide your flows into basically 2 different beds if need be. 600 is about the max, gallons per day in these systems before you want to look at starting to split flows if you're on, a residential or a commercial type application. Again, you're going to be dividing all of these flows. Distribution box layout is obviously coming into a distribution box here on this front left-hand side and going into all of the rows at the same time. That would be a level bed that you would go into. So you want to feed all of those as level as possible. D box at high side of the bed on the other side just shows the same type of application. We're feeding into every single one of these. You can do these on a slope if you so choose to as well. Multi-bed layouts where you can come inlet into these into a distribution box and then break off into both different sets of these beds if you need that type of system size, or you just got that many gallons per bedroom, that many gallons per day coming into the system itself. Again, each one of these would have a vent off to the end, and we'll get into that a little bit as we get through a few more pictures here. This is strictly a mounted bed. So again, if we go back to this, we just need to have a 12-inch vertical separation distance from the bottom of our 6-inch sand layer to whatever restrictive layer. So if we have a high water table at 8 inches, we can actually build this product up above grade and bring sand in to achieve that 12-inch vertical separation distance and actually make a system work. As I tell everybody, these again are minimum basal area sizes. So, more sand can always be used if you get into a situation where you're concerned. More sand is always a good thing to use in these if need be. Here is the small vent off to the end of these that you will see on every one of our systems. And that vent allows that air to flow through all of the pipes in the field themselves. When you come off of these wings here, you will definitely want to have basically a 3-to-1 slope that comes off where you slope per our manual. Basically that sheds the water off of the system and allows this to evaporate into this soil type here that's typically a better system soil that you're using than what came out of the ground. Again, just cover material to make sure that we're getting past our sand extensions here. This one is just showing a sloping bed up to 25%. That is our max slope that we can put onto these systems in the field. So the worse the soil, the less that slope can be used. But again, what we're showing here is just how the system sand and everything is laying with the contour of the soil. This is very, very important when we get into these, that this 3-to-1 slope gets tapered past the end of our clean fill of this 6-inch sand layer or 6-inch sand extension for disposal part. If you were to have any breakout, it would be here, just in the event on a slope side if they're using way too much water. That is something that we would need to consider taking there. So. The minimum drop to pipe when we are putting these crossovers in on the back end of these serial systems, we do not want this pipe to go into that offset adapter any more than about 2 inches. And if you look on the right hand side of this slide, you'll want that to be pushed up as high as possible. Again, this is due to possible liquid levels coming into the system itself. And we do not ever want these crossovers pipes to have more liquid in them than airflow could get through. So pushing those up and pointing them up as much as possible is exactly what you want to do. So that we make sure that we maintain airflow through this system at all times. Rules for the road, the geotextile fabric seam is always at the 12 o'clock position. It is labeled that way this side up, so you guys will actually know when you go out to do an inspection. The other kind of giveaway is the white 6-inch, bioaccelerator fabric that sits on the bottom of the pipe. It is a white barrier. So that way you know that that goes on the bottom. But again, the label noting this side up with the seam is always on the top. Rules for the rows continued again is a max row length for these is 100-foot maximum. Typically we go 70 feet on these as a maximum and recommended 30-foot minimum. If we are doing less than 30 feet minimums, I would really recommend that you reach out to us and let our engineers or our designers take a look at it along with your soil types. We typically don't let things go in any less than 30-foot minimum trench runs, just because we want these things to be more long and skinny and narrow than short and wide. We get a better treatment process out of it. A plus half-inch level end to end plus minus is what is allowed in these type of systems out in the field. So we just need to make sure that we maintain a level front to end on these. D-boxes and pumping. So anytime you are pumping up to one of these systems, you are going to want to come into a distribution box. We have to have not only the low vent on the outside of the system at the end, but we have to have a high vent, and that height difference needs to be basically 10 feet. So if we can come through the venting on the house, it is obviously much easier to do that. If we are pumping, you would have to bypass the pump tank and go strictly back to the septic tank for that. We've got some pictures for that. If you don't have that option to go back to the actual septic tank, then there is an option to remote vent right out of your distribution box and put that 12 or 14-foot high vent out there. You can also remote and move that away so that it's not out in the middle of, you know, someone's front yard. Remote venting is always an allowed option, and bypass venting is an option as well. And we're going to talk just a little bit about that here coming up. So if just showing that this is your low vent on the end of the system here, if you've got to go back, you can actually, you know, basically take that and slope that over to a tree or something like that. It's just, if you get some of these low areas here, you're going to want to drill a couple weep holes with a little stone here so that we don't basically fill this up with condensation over time. And so that it can just basically bleed out underground, and we don't get an air block here from the high vent to the low vent. So you can do that via the distribution box, or you can absolutely come back from the distribution box and pass the pump line and come into the side of the septic tank, or come into the front side of the T. So it will come here and vent back out of the house. Again, we've got to have a 10-foot elevation difference from low vent to high vent. That way it pulls a continuous airflow. Typically, you're not worrying about any of this unless you're in some type of a pump tank application. So again, if you're pumping, you would have to remote vent out of the D box, or you can bypass and come back into the septic tank so that it vents back through the home. Okay, system sizing. This has become very easy because we're starting to build some tools for you all in the field that I think are going to help everyone tremendously. So, so for field sizing, how much AES pipe is required and how much sand bed area is required? Always the amount of AES will be the same. So we go out with 70 feet of pipe per bedroom. In non-residential applications, or if you're in a commercial type application, you would divide your flow by 2.14 gallons per foot to get the amount of footage required. So just in your examples below, if you're doing a 3-bedroom, 210-foot Presby system, then you would have 3 rows of 70 feet. So 210 feet of Presby. If it was non-residential at 500 gallons per day, we take that 500 GPD and divide it by 2.14 gallons, and we would need 233.7 or 234 minimum feet required for that type of system. In in our actual guideline for the state of Illinois, and Illinois does have their own state guideline, and these are pretty much taken straight from the Illinois soils tables that we use to kind of give our reductions with our product. So gallons per day in square foot, the application rate and long-term acceptance rate. So basically we would take your current loading rate from your soil test, and let's say it was a 0.5 gallons per square foot per day. And for our sizing, you actually come over to this table B, I believe, in the manual, and you would compare it. Our loading rate for that is a 0.75. So as you can see, we get a pretty good reduction based on this technology and how we've approached the market in the field with NSF approvals. So at that point, you can come over here and know that it's bedrooms and gallons per day. So 2 bedroom, 300 gallons per day. It'll take you right down to the table here, and then it will give you what your square foot is required for the bed. When we get done with this model here, I want to go over something we have produced for the state of Illinois. So keep all this in mind, and we'll run through this at the end, and it will help you guys a lot where you won't have to do a ton of math. We have done most of that for you into a document. And I want to show that to you when we get done, and then it will be made available to any of you to use at any time throughout the state. So in bed dimensions, a 72-foot sand bed length using 400 square feet, it's basically 5.6 foot wide minimum. So 210 feet of that would be 3 rows of 70 foot. Just looking at bed dimensions again, and this is just kind of a snapshot of an overall system here. So this would be your 72-foot length, and again, basically it's 70 feet, but you have 1 foot of sand here and 1 foot of sand all the way around the outside of this. So our actual row length is 70 foot of pipe, but you have to accommodate a foot on each end of sand. So each one of these 10-foot sections has a coupler that they have to snap the coupler together. Again, this is showing a typical basic serial distribution again. So just like we spoke about before with these connections, they want to be raised. You want to raise these up as much as possible on the ends. And again, you'll have a raised vent on the back end here. This just shows the typical final grade of what the system would look like. There is a design worksheet for this, but again, I think we're gonna kind of pass through this because we've basically have kind of made something for you that I think you guys will like better. This does not work in this, so I'm gonna wait and go through the installation, and we're gonna come back to that because I think you'll like this tool that we've put together. So as far as installation goes, there's site preparation, there's field assembly, there's backfilling and site grading, the flow equalizers we talked about, and effluent filters, and we'll touch a little bit on just about all of this. So you want to remove all the organics, the grass, the shrubs, the trees, the stumps, prepare the receiving surface. So if you are going above grade on this, it is extremely essential, like you would do in a mound type system, to scarify the soils extremely well, just so that you get a good commingle of the sand that you're bringing in to match with that soils. Place the system sand the same day that you've excavated that system. We just seemed like it's had much better success doing it that way. I don't really want, I've had guys where they've dug the sand extension area out and didn't place the sand, and it rained the next day, and that kind of compacts that a little bit and makes it kind of tough. So I'd ask them to kind of scratch that back open a little bit if they're going to do that. Use track equipment to avoid all soil compaction. Most of the times that we're doing these systems, we're already fighting some pretty tough water tables or very heavy clay type soils. Compaction is not what we want on these type of systems. It just makes things worse. Keep water from running into or over the system during construction. So swales, berms, curtain drains, if need be, are very important to do. Obviously do not work wet or frozen soils, because they just don't perform the same way once you get those kind of laid in there and all that without some proper dictation. Again, the seam is at 12 o'clock of our product. The bioaccelerator is always on the bottom. It'll be at the 6 o'clock position. So that's the white fabric. Again, it's kind of a giveaway on it. Cutting the AES pipe, you can cut the fabric and with a utility knife and use some commercial shears if you want to. A saw or utility knife is used to cut the actual pipe. I truly don't recommend that a whole lot unless you've kind of messed with this a little bit. You need to make sure that you get your cut straight across, or it makes the couplers extremely hard to put this thing together. So most of our guys will just go up to a 5-foot increment or another 10-foot increment. And a lot of the times these systems are laid out that way anyway on the contour. So we try to keep that so that you don't have to do that. In some of the commercial sites, you may have to cut and use that type of an application. When you're putting the couplers on, they're going to pull this fabric back a little bit and they're going to snap this coupler together. Place the coupling under the pipe and clamp the coupler shut. I will tell you, this is much easier with 2 people than it is with 1, because you've got to make sure that you get kind of 2 of those slots inside the coupler. If you can see where my cursor is on the program here. And once you do that, then it will snap together a little bit easier. Once the coupler snaps together, then you want to pull that fabric back over the coupler as much as possible, just so that you keep sand out of there. Fabric over the edge of the adapter. Again, we're just pulling this just like you would on the coupler. Pull that fabric back as much over it as possible. That locks into that pipe pretty well, so you're not really going to get any sand. You always want the hole oriented at 12 o'clock position, because that's where you're going to put those adapters into. Again, I know that we've kind of hit this 2 or 3 times, but this is really important that we get this top of this elbow to push at least to the top of the AES pipes. You can see on the right here how much we've tried to push this connection up a little bit. Again, that is just to make sure that we get a consistent airflow through this pipe at all times. Even if we've got water, running from one connection to the other, we want to keep that air unobstructed and keep the flow going. Again, this is just showing the grade stakes. You can pull all these stakes as you go. When we backfill right here, one thing that you would not see in this picture is we would obviously be pushing these up as much as we can, just to make sure we get a really good sand layer and keep those things up as much as possible. We have all kinds of different methods. For the guys that have put in a bunch of these, they don't necessarily use the stakes anymore. They will use row spacing that they built either out of wood, PVC, metal. It makes it for an extremely easy install, because you can place that sand and the pipes don't wiggle in and out of here, and then you can just continue to move on down the system as we go. So it's an extremely good method. A lot of people won't build them unless they're actually doing, quite a few or several of these types of systems. Eliminate the sand void, so walk the rows in. It just allows for a really good, proper, no voids, no issue. You get a good sand layer underneath the sand beds itself. This goes with the chambers as well. If you're using septic chambers in the field too, it's one thing that a lot of people just don't do anymore is kind of walk these rows in, but it actually really does well. It keeps the pipes where they belong, and for an H10 load rate as well, keeps the compaction there. So as you're backfilling, as you can see here, these guys are using some of those pipes and stuff too. We just got to make sure that they're just kind of lightly sprinkling that on there. As you can see, this guy's in a track vehicle and he is literally on the sand extension. That is actually not an issue for us as long as you've got a track vehicle. No wheeled vehicles on this site whatsoever. Even when you're just digging the level bed or the pit out, we don't want any rubber tire vehicles on this whatsoever. You just run way too much risk of compacting the soils. These were the flow equalizers I was discussing in the original beginning. So these will go on the inside of the distribution box and they slide right into the 4-inch PVC that you've got coming into the box, there are multiple different flow equalizers out on the market. These are the ones that you adjust with just a turn of the knob here on the top, and this actually comes up and down inside here. You have them where you actually just turn the entire dial of flow up. So it's not, they're not all created exactly the same, and they don't need to be as long as they're doing their job. Just know that your distribution box over time, it will become unlevel because the ground's always moving. So venting. All systems have venting. Doesn't matter if it's a pump to, if it's a distribution box, if it's gravity flow, we have to vent all of these systems. Gravity beds use the roof stack vent. Add venting when you're pumping, along with what we discussed in all of our remote type applications. The vent opening is a foot above minimum of final grade. So if you're in a snow covered area, you know, that vent is gonna run up and down based on what your continuous snow melt might be. You don't want those vents to be below a snowfall. So I typically here in Missouri or in Illinois, a 3-foot vent is typically fine. And we do not use charcoal filters on any of this. You really should not be getting odor out of this system as it is venting from low vent to high vent, and it should be going out of the roof stack of the home. Do not plant any deep rooted vegetation or install irrigation systems over the top of the system. You shouldn't do that with any system, but technically here even more, because a lot of times these are high up in the soil horizons or above the grade, depending on what your soil types are. So as this picture depicts here on the top, you want to make sure that your topsoil is crowned to shed water off of the system. Any kind of drainage, curtain drains are great to use. Effluent filters. We do not typically allow effluent filters on these type of systems due to the simple fact that nobody is really actually out there servicing these systems. We call this a pretty maintenance friendly product here. So adding an effluent filter, although I truly love them when they are taken care of and there's a service maintenance agreement or something like that on the system, or if a homeowner will come out, if they do not go out there and clean that effluent filter on a regular basis, then we're going to start clogging all of our airflow that actually vents through the house. So for the most part, we just tell everybody no effluent filters on these systems unless they've maintained a service contract with a service provider. Here's my information. And Dennis Fogg, which a lot of you guys have done here in the past. This is my email. A lot of our guys have actually, I've asked them to send in their soils reports to us so that we can kind of work with some of these guys on their first couple job sites. We'll do some drawings for them. Some of the counties that have been involved with this has done has really liked the drawings that we put together for everyone. So that is something that you can use at all times. Dennis Fogg, myself, anyone in our company is happy to walk you through that. I don't know if there's any questions on this yet, but I'm going to get rid of this one so I can pull up one more thing and show you what we are doing with something else here as well. See if I can do this and not screw it up this time. Okay, so is this screen showing up on the screen? Are you seeing an Excel spreadsheet? Awesome. So fantastic. Cheryl, thank you for keeping your camera on too, by the way. So this is our this is strictly based on the Illinois code. And this is a document that I'm going to send to Justin. Chad Mormon has it at the State Health Department. We had come out with this in a little different process, and there was a lot of questions being asked. So basically, all of these yellow cells that you see here can be changed. So I'm going to leave this as a non-commercial system, and we're just going to do, say, a 3-bedroom house. Okay, and this is pretty slick because it helps all of you guys out. in the field themselves. And I'm going to say that we're going to go do a 0.3 soil loading rate. And when I click this, oh, I did 3 bedrooms, sorry. I'm going to come down here and do a 0.3 soil loading rate. And when I click off to the side, the yellow cell that says soil scientist that I just changed is going to change to a 0.3, but then right below it in the white cell below, it's actually going to size on the reduction that is allowed in Illinois. So you guys don't have to go back to the tables anymore to look at this stuff. They're literally just going to click off to the side. And now you basically have seen that 0.3, we're actually sized in Illinois at 0.4 gallons per square, 0.45 gallons per square foot per day. So then what it does is if we're on a slope, we're going to say that it's not a slope. So if you can look at this down here at the bottom section here, what this is showing you is it just changed all of this information and put it down here in a nice little drawing for you. So this little 6-foot cell right here that it's showing with 3 rows, it would be 3 rows of Presby. And then the rest of this is your 6-inch deep sand extensions, sand wings off to the side. Okay, so this is a level site. So we've got basically our whole entire system is 14 foot wide by 71 foot long. So that's the kind of area that we can come into. Now, if I go up here and put a slope, and I'm just going to put a 2 in here, I want you to look at the bottom again. All this 3 rows stayed the same, but now the 4 and 4 all turns into 8 feet of the slope because you're on a slope system. Everything is sloping to the right. So now that whole 6-inch sand layer is now on the bottom side of the system. So this kind of gives you guys, your contractors, a pretty good idea of how to size this without going through all the math. It will tell you, basically how many ton of sand is estimated to do this system right over here on the left, which helps not only the contractor, but you're all out there doing the inspections. So we've got a lot of guys using this that are printing these off and now taking them to you guys as the authority at the health department. So it'll also tell the contractor everything they need Presby product wise to put the system in the ground. So it's a pretty slick process, and it takes the confusion out. Now you can also come up here, and if you don't have 70 foot and say that we've only got 50 foot to deal with, then you can come up here and change your lengths, and it's going to change this whole entire thing down here at the bottom again. Now it's going to make it wider because we didn't have the length. So now we would be at 19.25 feet wide by 51 foot long. So it's just a process and a tool for you guys to have that it eliminates you guys having to do shorthand and math. It takes out a lot of the equation. And before we didn't have the basically the reduction built in. So you guys would have to go back to the chart, make sure the contractor was doing it right, and then come back out here and make sure you're hitting all your minimum and maximum on your square footages. So it's just a super great tool for you guys to have out in the field. And have access to, so that everybody knows what we're all looking at and how we're taking care of it. And if I have a little more time, I wanted to show one other thing. Are we still good on time?
Yes, you're still good. I think you have a little over 10 minutes left.
Awesome. I was hoping to maybe make up a little time for you.
No, that's good.
Let's see here. I'm going to, and this is something that will be coming out too. And I just want to make sure that this, let me know if this pulls up as well. It might take it a minute. Do you guys still have this? Do you see this screen now? Awesome. Okay. Okay, so I'm just going to buzz through a couple of these because this is something that's really important. I thought I was going to actually have for this meeting, and we did not get it done. But we have been involved in a project over here in the state of Missouri, and I'm in Kansas City, where we have to actually do a installation process here. We cannot bring in another state's data or an approval to gain an approval in the state. So we basically, when we purchased Presby in 2019, we had to kind of start over, which we had started with the old company in 2016 on some installs that had gone in the ground. So once we kind of started this process, is we molded the two installation protocols together. Many of the sites were 50 foot per bedroom here in Missouri, which actually all of them were, because it was pre us buying it. We're 70 feet per bedroom now. We had to renegotiate the protocol with the state because there was some things that just did not get done properly with the company Presby as a whole. And during the pandemic, when all of us were stuck at home, I was able to actually kind of run out into the field and actually literally start seeing all of these systems that were out there in the field. So there were 30 plus sites that we reviewed, and we just finished this up about a month ago. And this is what I wanted to share with you folks, because it's I'll just full disclosure. When we bought this product, I wasn't the happiest person in the land. The way that this company had somewhat pitched this product in the field just did not lend it a lot of credence. It kind of sounded like there was some magic going on with how these systems performed. And I just do not like to teach things that way or discuss things that way. So there's some things said that I think this would kind of clear up. But you know, the sand does a lot of the process. Where I always tell everybody, this Presby AES is a sand filter on steroids. Our product just happens to be a better vessel to kind of get this out into the field. So of these sites, we reviewed 30 sites in all different soil types that had to be in 4 different geographical areas of the state. And there were also 8 other sites that were reviewed previous to this. So there were 20 conventional sites that were 0.25 soils or better, and there were 10 additional sites that were less than 0.25. So that's kind of right up Illinois' alley with your lovely soil types up there. They're really, really a lot like what we have over here in Missouri. So out of those 30 sites that we reviewed, we actually came to one that we had an issue with, and it had some ponding. And I'm going to show you some of the pictures here because I think it's important just to have the discussion. This was sized at a 0.55, which with a reduction, they got a 0.65 soil loading rate in an area that is typically 0.2 or 0.25 soils. So I don't know how it got past everybody, with the exception of that this was one of the very first systems that went in the state of Missouri. And it probably just got past some folks at a regulatory authority too on to how it got passed. But anyway, I was actually, you're going to laugh at this, but I was actually glad to see a failed site, because 30 out of 30 just doesn't sound good. I've done a lot of these tests in the field before in the past, and there's always a site or two that you're going to have issues with, whether it's your fault, homeowner's fault. There's plenty of blame to go around on these job sites. So we were able to go back on slope sites. We basically got the full-blown state approval. We did present this at the National NOWR conference last week. We just weren't able to finish everything up. So the couple takeaways I would say for this is, in the 0.2 soils, it's highly recommended that 3-to-1 slope that you cover the toe of these systems, that you pass that toe of sand extension. I mean, if you're going to stop right at the sand extension, then push the sand extension further, because we're asking those 0.2 soils to basically take effluent. Makes it very tough for them to take if you don't have some of it knifed in the ground. And then scarifying the surface of the soils before that sand layer gets put in is extremely important in the field. So this was the job site that actually had the issue with, and I kind of just wanted you to see it. So that whole entire footprint right here for a 3-bedroom home is right in this spot here. They are actually parking cars right here next to the top of the system. So our pipe actually starts right here. There are 5 rows of 40-foot lengths of pipe here, and sized at a 5.5 with 6 people in the house. So it was rutting right out here on the side. If you can see this picture, the next picture shows it from the road. So literally, this was all of the sand extension that there was on that job site, and it's not even close to being what it should have been to be a legit system. Now, I will tell you, they dumped this into a road ditch that goes right into a curtain drain. No odor, no smell. No issues. I'm not going to tell anybody that anybody should ever drink that effluent that comes out of it, because you shouldn't. But I will tell you, after reviewing about 60 or 70 of these sites, that was the one thing I noticed, that even the ones that did have issues, There was no smell, there was no issue outside of the home or in at the field itself. This is a 0.2 gallons per square foot per day, 4-bedroom. So you can see the small candy cane system that's here. This is the low vent, and this is not a pump system. So it runs right back into the concrete tank and runs right out the roof vent of the house. So that's our huge elevation difference to high to low. It's pulling air in here, goes through the system, and then runs right back out of the top. And there was tons of these. So you look at this kind of slope on this one here, and this thing was just brutal. But what they did is, if you can see what they did, is they came down, burned this up here really nice with a curtain drain and a little drain in front so that it would take this water and dump it off the sides. And then this is the end view of that system. And we do have a little bit of vegetation issue here where it just doesn't grow well enough. And I think part of it's because they don't have enough diversion here coming out. But it was just site after site after site that looked like this that we went to, that this is the entire system here. So this one's on a slope. We've got 6 people in this house in a 3-bedroom, and there's about a 10-foot sand extension that's all covered up right here. There's your low vent, and the high vent runs right back through the house. So it was just really neat on how some of this was done. This is a pump 2 system. So we pump to the distribution box, and believe it or not, right there is your vent. They vented that right off the distribution box and hung a flag on it. So there's all kinds of different ways that you can hide this stuff out into the field. This was another one that was way far away from the house, but a really slow, gentle slope down to the bed. There's your low vent, high vent went right back through the system, back through the house. I did want to touch on this one because this is exactly what I was talking about with, you see this photo on the left, your low vents are here and your high vent is here. So if you see that the picture on the right hand side, I don't know if you can tell how aesthetically ugly that actual high vent looks. You could actually remote vent that even back up to the house and run up the side of the house or run it up a tree or spray paint it camouflaged, or we've got birdhouses you can put on them, or all kinds of stuff that you can do for that. So that's really why this is a pump 2 system, and that's why I really like showing this one, because there's a million ways that you can kind of hide this and make it look like part of your landscape to a degree. And then finally, I do, for those of you that have heard me talk, I do like to talk about failed job sites because we all have them. And this was one where I was talking, so it's a pump 2 system. The house, it's not this house. The house is actually back on the other side of this tree line. And what happened here was there was no soil over the sand extension. So you've got the bed here with the pipe in it, then you come down to that 6-inch sand layer, and it was bleeding. When I first went out to that job site in 2019, I was walking on sand. There literally was no soil placed on top of it. And me not knowing enough about the system at that time, didn't realize how bad that was. But knowing it now, we walked it, we dug into the sand, we had it tested. The testings came back at NSF 40 in the single digits of teens of TSS and BOD. There again were no odor. The problem is, in the state of Missouri, once that comes to the surface, it is deemed a failure. So we came back in with the site, the picture on the right, and we came in with 2 more truckloads of soil and reseeded. We went back and reviewed 2 of those as well in this study. They came out perfect. So we felt like we really kind of changed the process, and you can work on these and actually do some repair work to them. And then this is just the last picture I was going to show you, but this is the kind of stuff that we will do for you guys on your first job sites, or your contractors' first job sites. Is we want them to know what they're doing. So if you'll send that to us, we really want to be able to give them all of the data and information to make their job site successful. I will also tell you that in the state of Illinois, we do require them to be certified, and we have an online certification program that I highly recommend you, as the local sanitarians or inspectors, go through it too, because then that way you'll kind of know a little bit more about the system. But it takes you about 30 to 40 minutes to do the test and to watch the videos, but it walks through everything that we just spoke about today. in a much more user-friendly fashion. It's tough to cover all this in about 40 to 60 minutes, but that's kind of it in a nutshell. But this is the stuff that we would send back to either your contractor or you guys for you to take a look at, where we have your design loading rate with a nice little drawing on there. Then from there, those guys pretty much can use all of their, the Excel spreadsheets that I'll be sending as well, where you can use that program to do most of this design and take care of all of that. So with that, I'm happy to take questions or whatever you guys might have.
Does anyone have any questions in the audience here? Live? No? Okay.
Good. I'll stop sharing. I'm going to send this this program over to Justin today too, so that he's got all that information. And I would love, I'm not sure if I should send it to you as well, so you can send it out, but it's welcome to go to anybody that's there.
Okay, no, that works. You can send it to Justin and
Okay.
hopefully he'll send it out to everyone else as well. That works.
That would be fantastic. Thank you very much again, folks, for letting me come and talk to you. I appreciate your time today.
Awesome. Thank you so much, Curtis. We really
You
do
got it.
appreciate it.
Yes, ma'am. Y'all take care.
All right. Thanks. You too.
Bye-bye.
All right. So as we are transitioning, it looks like next up we have Mark from CDP, who's going to be talking to us about data analytics. Mark, are you online?
I am. Can you hear me?
Okay, perfect. I can hear you. Mark, if you give me 1 second as we transition, I'm going to try and switch us to a Bluetooth speaker. So I'm going to pause the recording real quick and hopefully it'll like sound louder in the audience. Give me 1 second. All right, thank you for your patience. So I'm going to go ahead and turn it over to Mark, who, like I said, again, is going to talk to us about data analytics. So Mark, you can go ahead.
Okay, thank you. Wow, lots of content. You guys have been powering through a ton of content, so I hope to try to make this fun and interesting for you. I know I get the coveted position right before lunch, so we'll do what we can do here. I'm just going to say hi for a minute, then I'm going to switch over to screen share and do that. So yeah, my name is Mark McNutt, and I work with Mike Peth and John Grady, if you know those guys. We're from CDP, also known as Custom Data Processing. So I lead our data team of data engineers, and we work on public health data analytics. So we have over half the states in the country for the WIC program, the Women, Infants, and Children. We work with a large state on SNAP data analytics, and we also work with EMR, electronic medical health records, and with you guys with environmental health content. So that's to hope hopefully gives you a little background of what we're about. So really hoping just to talk about how we can use data in a way that's interesting and can help you out. So I'm going to switch over to a screen share. Hopefully this will work. That would be this one. Okay, is that working okay?
Yes, that's working.
All right. Turn my camera off. All right, cool. So I'm gonna do just a couple of PowerPoint slides and then get mostly into working with data today. Basically, I have two goals, and that is just to give you a sense of how these modern data analytics and BI platforms like Tableau, which is what our product is called Data Direct, and it's basically built on top of Tableau. So, it's web-based and all that, and, want to just show you how you might use data to better manage your program and improve your program using data. All right, so we're going to focus on one data mart, and a data mart is just a collection of data, and that is inspections of establishments and any resulting violations that come from those inspections. And the goal is just to get you think about how we might put this data to work. All right, where is my crazy little PowerPoint deal? Here it is. Okay. So, we want to establish a data culture at our organizations. And the reason for that is we want to make better decisions and guide our program in the way that makes the most sense based on our data. We want to gain insights from, we're all on electronic systems. We have the data, So it's always just a big challenge to wrangle the data in a way that's updated and available to you, organized into these data marts, and then we can start to work with it and ask questions of that data, gain that insight. And, a lot of times we have gut feelings when we make decisions, but if we do have the data to back it up, that's going to be more powerful for us, and hopefully have better outcomes. Another concept with data culture is democratization. So the idea is that everybody can benefit from having data, no matter what you do at different levels, whether you're federal, state, local, county, whatever you're doing. If you have relevant information available to you, hopefully you can make better decisions. So I mentioned Data Direct is our product that's built on Tableau. If you haven't, there's other products like Power BI, or there's these modern data analytics platforms. They're web-based, they're drag and drop. You can build dashboards and save them and share them. And I'll just give you a demonstration of some of that. Quick slide on data flow. So you have your systems and the data flows into the data warehouse system. And there's different ways to do that. Like I said, that's part of the biggest challenge, and a lot of the work is wrangling that data and organizing it into a way that makes it useful for data analytics. So like I said, we're going to talk about inspections data, and this is a picture of what that data mart kind of looks like as we play around with it. You have different dimensions like time, like when did that inspection take place? How many inspections did we have? What violations did we have? So we'll delve into that. Data dictionary. So it's good to know when you're working with your data, like what each data element means in there. What's the definition of it? So we have a dynamic one where it's just available right there inside the tool, which can be useful. All right, enough of that. Let's jump into demo, straight into it. So here's what you might see when you log in. And I want to say thank you to Utah, Salt Lake City specifically, for letting us work with their data and show what we've built for them today. So that's what we're going to be working with. And you see there's that data dictionary I mentioned. We've got some different folders. So this is hopefully pretty intuitive Tableau. We're going to start out, we're just going to go directly into a sample reports folder, and you'll notice these little people icons. A lot of times this will give you a thumbnail image of the report or dashboards that are in this thing. That is not doing it here, because the way this works is it dynamically shows you the data that you have access to based on your health department. Again, back to that concept of democratization. You only want to see what's relevant to you. So I'm going to go into this establishment inspections reports and just open up this first report. And this is kind of like Excel. Like there is a workbook, and then there are sheets or dashboards or reports within each workbook. So this one has a few reports in it. I'm going to blow this up into full screen mode. And hopefully you can all see this okay. And let's just talk about this report. So we have placed some establishments on a map in Salt Lake City, based on the latitude and longitude from geocoding that data, where we give them an address and we get a latitude and longitude. So we can show you, where these guys are at. And then when you hover your mouse over an establishment, you're going to get some extra information, like their name and the type of establishment they are, their address, how many inspections they've had and the time frame you have selected. So that's another thing to mention. On the right, we usually have filters. So we have a lot of historical data, but we're filtered in for some months here in 2022, and we can add some data in. We can add a few more months, and our report will update to include that extra data. We can filter on different types of establishments. I have this filtered to kind of food-based, restaurant-based establishments. I can sit here and select everything, and we're going to see a lot more. I'm going to undo that because that's just too much. And you can design these reports to have whatever type of filters you want. I could say only show me establishments that had at least 15 violations, and that's going to limit the number of establishments that shows up. And by the way, when I'm when I'm hovering my mouse over one of these and it's showing me this report within a report, it is in context. So I can see the violations that are related to this particular food and sweetie market. And by the way, that's this report right here. So if I click this tab up here, this report is just showing me, okay, what are my top violations based on what I have selected in this time frame for all different types of inspection types. And here's the winner right here. So what we're doing is in this other report, it is dynamically filtering. So when I look at this restaurant, it's only going to show me the violations that are associated with that restaurant. Okay, moving on. Here is an inspections dashboard. I'm going to show just a few more reports. So this one is just showing us inspections by zip code, top establishment inspections, like how many, which establishments had the most inspections. And because this is a dashboard, I can always click on something like this zip code, and it's going to filter everything else in the dashboard to see the relevant data. So down below over here on the bottom right, we have our top inspectors. So the inspectors that have had the most inspections over this time frame. Here's another one that focuses in on violations. And here in a minute, we're actually going to build a dashboard together. I'm going to click on, in this dashboard, if you click on an establishment, it shows you the details of the violations down below. Last one in this workbook is going to be showing you by establishment type and inspection type the average violations per inspection. So we're looking at a downtrend here in this particular data, going from maybe around 3.5 down to more like 2.1 over time. So we might want to figure out what kind of measures that we're interested in as we think about reporting on inspections and violations. Okay, so one thing when you're using this tool, when you're using data analytics, you want to know yourself. Are you the type of person that wants to just use the reports that some data analyst or someone else has created and work with them to get those reports created, and you want to be able to consume those reports to do what you're trying to do? That's one type of person. Another type of person might be someone that wants that if they don't find the report they need, they have a particular question of their data, and they want to be able to use a tool like this to answer that question. That's kind of the second group. And then the third group would be your power users that are data people, and they need a certain type of tool as well. So focusing in on that second type of group, because there is quite a bit of a learning curve when it comes to building advanced reports, and here in a minute, we're going to do that. And, a lot of people may glaze over for a minute because it's just like, whoa, what's going on? So the idea with a couple of these tools here is to make it a little bit easier. So this is something called Report Builder that we came up with. And I'm just going to go into this. There's a little bit of there's a introduction kind of how-to type of documentation. And then I'm going to go into this bars with trend. And this is specific to the establishment inspections data mart. So when you come into something like this, you want to have a question in mind. So let's say our question is, which establishment had the most inspections last year? So the first thing I might do is come in. I've got all my historical data selected. That's a lot. So I'm just going to come in here and just select, the months for 2021. So January, just go through and just select some of these guys. Okay, so now my report is going to just show 2021 data, and I have a daily trend. And so instead of doing something advanced, we're just going to use these drop-down lists, and it has dimension 1. So I'm just going to go find my establishment name, and I'm going to select it. And just like that, it's just going to print out all of my establishments. And then I need to select some sort of measure, which is our numbers. So I'm going to select my total number of inspections, inspection count. And just like that, it's going to show me, I'm going to full screen this. It's going to show me the overall number of inspections during my time frame in 2021. And it's going to show me which establishments had the most inspections. Now, by the way, if I make mistakes and I say something stupid, please forgive me. I'm still a little bit new to this data. But I do know that Subway, is a chain, and that there's probably several Subways. So instead of selecting the name, I'm actually going to change this to the unique identifier for that establishment. This way I know I'm just going to get one restaurant. So this particular restaurant is the one that has the most inspections. And let's go ahead and add back in the name so we know which one that is. There it is. And let's also add the type of establishment this is right there. And while we're at it, let's throw in the number of violations as well, because I have the option with this tool to select two. And this daily trend chart is a little busy, so I'm going to change this to monthly. And there we go. We've got our monthly uptrend of inspections and violations in 2021 as maybe COVID stuff dissipated a little bit. And if we just want to get crazy, let's just select everything and see what that trend looks like. And we've got some bad data in the future here. But ignoring that, we can see that big drop, right? That big drop in inspections and violations that happened around COVID. And by the way, since this is a dashboard, I can click on a particular establishment and look at that. I'm going to see their particular trend. So kind of a good tool. And just to show you real quick, I'm going to kind of set these to none and just change this a little bit real quick. And by the way, you see the performance in the number crunching with all this data. It's doing a good job of rolling it up. Tableau is done a pretty good job of making things pretty fast. All right, I'm going to set this just to establishment type, just so I can show you some of the other visualizations. So now we're looking at inspections and violations by establishment type, and I can look at different visualizations. Tableau came out of Stanford, where they were learning that the way people relate to information, if you visualize it, you can quickly see things like, oh, wow, okay, gas IM program is the one that has the most inspections. I can look at it as a pie chart here, a word cloud, and then a scatter plot. This is going to show the relationship between two measures. We'll play around with that more in a minute. And then we have a map dashboard, so you can look at things from a location perspective. All right, that's one tool. One other tool is going to be called Ask Data. So what Tableau's done with this tool is to try to give you an interface that's kind of like a Google search. But really, you could almost see it as another report builder. Again, for people that don't want to go too advanced, but they have questions. So I'm going to type in a question. I'm going to say, I want to see violation count by inspection type for inspection date of 2021. Kind of the same thing we were doing before, and then just hit enter. And this tool is going to take my question and attempt to answer it. And you can see it translated my question into a measure, a number that is violation count. And it's going to slice and dice that number by inspection type, because I said by, whenever you see the word by, that means you're trying to slice and dice it by a dimension. And then when I said in 2021, it translated that as a filter for last year. And I can click and actually add other filters based on any of the data I have, or I can add more dimensions. I can change the type of visualization here. So if I wanted to change this as, maybe I could type in here, you know what, I want to see over time by inspection dates week, or something like that, by week. So then now, since I said over time, it figured out I want like a line chart. And maybe I just want to interactively play around with this. There are so many routine inspections. I just want to get rid of those. So I'm going to click it and say exclude. And my data updates, and I can see some of these other inspection types and their numbers. All right. Moving on, let's get into the advanced. Now let's pretend we are an advanced power user, and let's build a quick dashboard together. So I'm going to come into what's called create your own report. And all this is a starting place to build a report. And there's some documentation here on how to do that. But I'm going to go straight into this template report. And I'm just going to hit this magic edit button. And when I click the edit button, that brings me into the drag and drop ad hoc reporting mode. And I just want to explain for a minute, here's some different data marts that I have available. We were talking about septic and wells in the last presentation, requests for services, certifications, accounts receivable. There's probably more data marts we can bring in here for sure. But like I said, today we're focusing on this one, and you can see it's organized into folders where we have information about our establishments. And we have a folder for our inspections and a folder for violation data. And then down below, we have all the numbers, the math stuff, all of the measures that we might want to focus on. And our current report is showing us the total number of inspections for September 2022. We're just going to make our own. So the first thing I'm going to do is just clear this report out a little bit just by right-clicking and deleting all this other stuff that we don't need. And the dashboard that I want to build is I want to focus in on inspections and violations and the relationship, between those two, and to just be able to report on those by things like inspection type and establishment type. So the first thing I want to do is a trend. So so what do I need for a trend? I need a date. Okay, what date do I want? I can come into the search bar and search the word date, and I can see all the different dates that I have available, which is a lot. But I want the inspection date. So I'm just going to double click it, and that gets brought into my report, and it just added it as a year right there. There's a nifty trick right here. I can say show me, and I want to change this to a line chart. So I'm going to click line chart. And because I only have 1 month filtered, it's just giving me a dot. That's no good. Let's add more data. Let's add just a bunch of data here. All right, good enough. Go back to 2021. And instead of year, I'm going to change this to day. So instead of year, I click day. And there we go. Actually, that's pretty busy. Let's go for a week. And I can click this letter, this letter T, to show the numbers on the chart itself. And I can go over to my analytics pane, and I have some different, things I could add, like a trend line. So I'm going to drag a trend line over here, drop that on there, and we see that uptrend that we saw before. And I'm just going to right click, and I'm going to call this one trend. And look at that, we created a report. All right, so the next thing I want is a report that shows me inspections by inspection type. So I'm just going to click this icon to create a new report, and I'm going to clear out my search. I'm going to go into inspections and find inspection type, and I'm going to drag that out here. And I'm going to go for my inspection count, double click, and there's my numbers. And I can, again, play with the visualizations, and I'm going to do a tree map. And we can see the routine inspections are the largest value here in terms of the number of inspections. We should probably add a, let's see, well, we did that in the one before. Okay, so we have, let's just rename this to inspection type. And guys, I'm going to move really quick just for time, and don't feel bad if it's just like, what the heck is he doing? I'm going to right click and duplicate this one. And I'm going to rename this one into establishment type. I could type, and then I'm just going to bring in, I'm going to search for the word type, and I'm going to bring in my establishment type instead of my inspection type. And now we're seeing that data. All right, so now we have 3 reports. So let's build a dashboard. I'm going to say dashboard, new dashboard. I'm going to blow that up a little bit to an automatic sizing. And then I'm just going to drag in my reports. There's inspection type, there's establishment type, and then I'm going to bring my trend in. Okay, I'm going to do a little bit of formatting here. Just fit by width. Just kind of blow that out a little bit. And okay, so you would think, okay, this is a dashboard. Whenever I click, it should update, right? It doesn't do anything. So I have to teach my dashboard that when I click it, I want it to filter the rest of the report. And there's a button right here to do that. I'm just going to click it. I'm going to do the same thing for this one. So now when I click on one, everything else will update to just that type of inspection on samples. All right, another thing is, let's get rid of that. I have my date filter on inspection date. You'll notice if I come in here and select everything, watch what happens. You notice that my trend chart updated, but these other reports did not update because they are not connected. So I'm going to back out of that. And then I'm going to teach this filter. I'm going to say apply to everything using the data source. And there it goes. Now it updated. All right, great. So we've got our dashboard. I'm going to do one more report real quick. I'm going to do a scatter plot because I want to focus in on this relationship between inspections and violations. So I'm going to go down to my measures and I'm going to find my inspection count, double click it, and then I'm going to find my violation count. And by the way, Tableau is trying to figure out what I want. It says, okay, you have 2 numbers. Maybe you want a scatter plot. So it did that. It just has 1 dot on the screen because I'm not slicing and dicing these numbers by anything. So let's do that. Let's show a dot for every establishment. So I'm going to take my establishment ID and drop it onto detail. And this type of report is great for finding outliers. Because outliers, they may have something going on that's outside the norm. So I'm going to change the shape of this. I have some control on that. Another thing that data analytics can be good for is data quality. This one out here is probably some sort of error, I'm guessing. So I'm just going to click it and just exclude it so it doesn't mess up our report. And then I'm going to color code by establishment type. So where's my type? There it is. Drag it onto color. And I'm also going to display the name on here as well. So I'm going to drag that to label. And now it's going to show me if I click on my different types, it's going to highlight those that match it. Okay, and now this is going to be, I'll just call it scatter plot. All right, let's go back to our dashboard. And let's add this guy in here as well. All right, there it is. So now when I click on routine, I'm going to see all my routine dashboards, and that's filtered. And I could click on food service. And I can see that, some of these establishments had a lot of violations over here on the right, and also a lot of inspections. Maybe we can find something different here. Oh, by the way, to help us better understand that relationship, let's go into this trend chart and let's add in the violation count as well. So I'm going to drag that over onto rows. And there it is. So we have inspections and violations, but I want to show this on one chart that is called dual axis. So I'm going to do that. But now I have 2 different legends, if you will, over here, or I don't know what you call that, values over here. So I want to synchronize these, and I can do that by double clicking on the header and say, okay, synchronize those dual axes. So now we can see the inspections and that trend. And we can see, I guess, probably since COVID, let's go ahead and add in some COVID months in here. Let's go all the way back to before 2022. And look at that. We had our inspections and we had a whole lot of violations. After COVID hits, our number of inspections and violations plummets. And then now we've slowly been, I guess, giving out more violations over time there. And now it's uptrending. All right, so if we go back to our dashboard, since we changed that date filter, we're now going to see that across the board. All right, so we've built a dashboard. Let's save it out so other people can use it. So I'm going to say File, Publish As, and I've got an area called Custom Reports. I'm going to put it there. I'm going to say Inspections and reverse violations. Publish it out there. So now that is going to be saved. And I'm going to go to that report that we just created. And there it is. And now I can do things just like any other report in the system. I could subscribe, so I get this in my inbox every day or every week or every month. I can set up data alerts where certain conditions are met. I want to know. I can export this report as a PDF or Excel or PowerPoint or Tableau if you're advanced. Yeah, so there is creating a dashboard. So hopefully that gives you a sense of, that type of advanced users experience in this system. All right, so the last thing I have for you today is just to kind of throw out some interesting report ideas. And a lot of these aren't fully fleshed out, just kind of to get us thinking. So I'm going to go to a report I have over here, this guy right here, and just talk through a few things. So a lot of these reports are going to be around geospatial analysis. So like I said, we're geocoding these establishments. How could we put those together? And I know we had some conversations with the folks from Salt Lake City, and we were talking about things like, using data to plan out future inspections and kind of parsing out the inspections out to different inspectors, and how, maybe without having to do a huge Excel spreadsheet that takes a lot of time, maybe if we have the data in a system like this, we can do that a little bit more easily. So this is using clusters, where it's the system itself is organizing the establishments using some sort of, advanced AI or machine learning, something that I don't understand. But you can teach the system to cluster the establishments based on things like their location, which is what it's doing here. But you could also add in other things like, the type of establishment. So you want to cluster them based on that, and you can tell it how many clusters you want it to create. So that's one thing you could do. Here's another one, calculating that someone on my team, Darren, developed. He just pulled out some data specifically for Salt Lake that is, I believe it was from Google, and this is drive time. So you could see from, downtown Salt Lake City, what does it look like if you drive 60 minutes? And that's what this is showing. These outer borders are 60 minutes. I can come in here and toggle this down to like 30 minutes, and it will update and show how long it would take to drive 30 minutes. So this gives you an idea of how long an inspector might be, driving out there. Okay, so this one's fun. I'm going to go full screen. So what this is going to be showing us is from the environmental health office in downtown Salt Lake City. I basically took that point on the map, and then I said, okay, give me all the other points that are establishments out there and calculate the distance between the two. So if I, hover my mouse over one of these, I can see that this establishment is almost 12 miles away from the office. So what this dashboard is showing us that the average miles is around 6.68 miles. And we could hone this into particular types of establishments if we wanted to. We also have broken down by inspector, the average miles. So you can see which inspector is having to drive the furthest on average and which inspector is driving the least. And when we click on an inspector, it's going to show us the establishments they're going out to and where they're located. So, and then we could see if the ones down here at the bottom, those are going to be closer to the office. So kind of cool. That is that report. Let's go to the next one. It is establishments. Okay, so this is just, I don't know if this is true. This is maybe one of those, he doesn't know what he's talking about, but establishments further away get less scrutiny, ? That's the idea of this report. And I just wanted to show, how can we use this distance data in a different way? So this is showing us the average miles to establishments. So over here on the right, this is going to be the ones that are further away. And the ones in the middle are kind of medium. And then on the left, we're looking at the average number of violations per inspection. So you can see that's some of these have a high number and some have a lower number. And since this is kind of downtrending as you go, is it true that the ones that are further away maybe get less scrutiny? I don't know. Okay, so that's that workbook. Let's look at a few more and then we'll wrap it up and open it up for any Q&A you have. All right, so another thing that I kind of thought about when it comes to inspections is how long do these inspections take? So when there's a routine inspection, I have this filtered for routine. We could change the filter and look at, other options, and the dashboard will update. But this is showing us that for routine inspections, the average time that inspection takes is 40 minutes. And this is out of near 500 inspections with 4,000 violations. I'm picking on, I think, restaurants again here, but I have this filtered. Otherwise, it would just be a ton of data. And I'm looking at the last 3 months. So down here, I have my map and I can see those establishments. And up here on the left, I have which inspection took the longest. And I see this particular one. And if I hover my mouse over, I can get some more information. And this took 130 minutes. And then I can see, if I scroll down, I can see some inspections that were short. I can click on I have the inspectors that had the longest inspections. So if I click on this inspector, I'll see the establishments that were inspected and how long each of those took. So this might be, when it comes to resource allocation, working on, hey, we're going to set a goal to reduce our inspection time by 20%. And you could use a report like this to track that. All right, last one. So this is something that I believe we talked with Salt Lake City that was kind of interesting. So you have in the system a data element called next inspection date, and that's being displayed here. So what this report is attempting to do is to show you your upcoming inspections. So this is filtered for, inspection dates into the future. And this parameter right here is called numbers of days in the future. So I have it set to 5. So what this is doing is today is November 8th. So it's showing me the inspections that are scheduled for tomorrow, November 9th. And if I scroll down, I will see up to 5 days to November 12th. And just a little bit of extra data, number of inspections, number of violations. And I have that broken down over here by food services. So in the next 5 days, we've got 33 food services inspections scheduled. I can click on that and focus in on that. My non-plated restaurants, here are the inspections that are coming up. I could also bump this out and say, show me the next 30 days. And now we've got a lot more inspections coming up. All right, so that's pretty much what I've got, and I will pass it back to you and open it up to QA. Thank you for your time today. I guess I wrapped up a little early, so I know that's probably okay with lunch coming up.
Does anyone have any questions either online or in our group here? Oh, yes, there is a question.
Regarding, is that data available to the general public?
Okay, there was a question asking, is this data available to the general public?
No, it is not. Although, in the Wix space, we've done something where in the system, you have to have a username and a password to get into it. And you can set it up, like I said, to where it'll only show you the relevant data for you. But we've worked with some states in WIC where you can embed these reports in a public website. So if your agency has a website that's customer facing or even, a website for your inspectors, you could embed some of the reports you want them to see, and they don't have to have access to this tool. So it's kind of an add-on feature that Tableau has. We can set up.
Okay, does that help? Yes. Are there any other questions in the audience or virtually? No, let me check the chat. Nope, I don't think so. If there are no other questions, then I think we're good to go. I want to say thank you so much. We really do appreciate you taking the time to share this information with us. For anyone else who's on, I'm going to leave the Zoom open. I'll just pause the recording, and then when we kind of reconvene for lunch, I'll then let people in if anybody is joining or anything like that. But thank you so much, Mark. Really do appreciate it. For everyone else, please enjoy your lunchtime, and I will see everyone back at, I believe, 1:30. So, all right. Thank you. Bye. All right, hello everyone. Welcome back from your lunch break. We just have these last two sessions before we conclude our virtual room today. So next up we have Dewey from CMAHC, and the topic today will be Model Aquatic Health Code. So Dewey, I'm going to turn it over to you, and if you need any assistance with kind of getting the slides up, just let me know and we can get started.
All right, let me share my screen. There we go. All right, cool beans. So thank y'all for allowing me to be here today and for the invite to be here today. It's always great to talk with health code folks across the country. So as Amy mentioned, my name is Dewey Case. I'm the technical director for the Council for the Model Aquatic Health Code, commonly known as CMAC. And our big role is we are responsible for helping CDC and updating the MAC, providing technical support to the industry. Those are our two big roles contractually and as an organization, right? So today we're going to talk about the MAC, Model Aquatic Health Code, and just what it is, what it's about. Talk about the structure, organization, how it was developed. I do want to give some time for some good Q&A towards the end. So if you have questions, throw them in chat. Amy and I can sort through those as we get through the presentation. And we'll be more than happy to have a nice open discussion. It looks like we have a pretty small group. So let's get a chance to just dive really into it. So the first thing on the MAC is quite simply what it is, right? So the MAC is an all-inclusive model code developed by CDC. You know, it's got its roots very early on at a conference in 2007. because there was no comprehensive code, right? There was nothing that dealt with all aspects of the pool, and certainly not one that was had a public health focus. So that's kind of the root origin of the MAC. I'll talk more about that in just a minute. But it's an all-inclusive code. It's really unique from other codes in that it covers from before you even dig all the way to people in the water. So it's not just a sectional thing, right? It's not just the building. You got to look at other standards or other items. You can really refer to the MAC in its entirety for all aspects of construction, design, operation, and maintenance of an aquatic venue. It's entirely voluntary, right? Being the CDC, there's very few the CDC can do that is a mandate. By federal law, it is unable to produce mandatory guidance documents or mandatory codes, right? So it's intended to be a voluntary guidance document to help folks like yourself, environmental health professionals first and foremost, but also to help the industry operators, builders, managers to have the best science and best practices to help all of our health officials have the utmost and really safe, really healthy public pools, right? And commercial pools. It is only intended for commercial pools. There's not a single section in here that applies to residential. And that's one of the big differences, right? So if you look at other codes, let's say the ISPSC, that can defer to residential as well. The MAC does not play in that space. It is only intended for commercial venues, right? And when we look at the MAC, it talks about all aspects. I mentioned that earlier. We'll talk about it more in just a second, from the plans all the way down to people swimming. The MAC is currently updated every 3 years. It is open for stakeholder input. You do not have to be a member of CMAC to submit a change request. In fact, we had a gentleman the last update cycle that he was a swimmer. He swam at a pool and he thought there was an issue, so he wanted to address it through the MAC. But every 3 years it's updated through a very comprehensive process and then ultimately released for public dissemination rather, and use. Okay. With the MAC, you have two different aspects. You have the MAC itself, which is the MAC code language. Again, it's comprehensive with 3 primary sections: design and construction, operations and maintenance, and policies and management. As I mentioned, the MAC is intended to be data-driven. It is product neutral. There's not a single product recommendation in there. You're not going to see the MAC calling for any program, any controller, any filter, right? There's not going to be any of that. It's product neutral. And its primary goal is science, right? That's the first thing. So when you look at a recommendation in the MAC, everything has to be either science-based or an identified best practice. Because let's be honest, there's many things in the pool world and the aquatics world that we don't have science on, right? It's best practice. We have some things that certainly we can look at other fields, engineering fields, plumbing, et cetera, to get some ideas and to get some guidance. But the science oftentimes is lacking on many, many aspects, especially the management side. Outside of the code language, you also have the MAC Annex, right? So the MAC Annex is a very large document. It's actually larger than the code itself. And this is where the discussion occurs. This is where, as a reader or as a user, you can go back and defer to the Annex to help understand more about why UV is required on splash pads, right? Or why we have this particular section of line in training programs for lifeguards. And it's really, really valuable background data. And they're intended to be complementary of each other. They're intended to be used simultaneously. And we found through our conversations with health officials that the MAC Annex is super, super helpful, specifically in whether it's a code adoption from the MAC itself or just in something you're wanting to see changed in your local code. It's very, very helpful in justifying that particular change to the powers that be and legislatures and leaders at the health department level. Okay. So the big thing about the MAC, and this is where it very differs from other codes, is that it's a public health document. Plain and simple, right? Everything about the MAC from beginning to end is intended to be protective of public health. And to emphasize this, right, public health officials have a huge impact on the MAC and a huge voice in the MAC. We see this through by ensuring that public health officials are represented at every level, from state and local and county level. We see where on our committees, where there's public health representation on each committee. And when it gets to the technical review committee, which is the overreaching committee that guides the MAC update process, it's composed of at least 50% public health. So we see this, and we see this commitment to public health by having environmental health officials and other public health officials, epidemiologists, et cetera, have a very heavy hand in the MAC. In fact, another way this is accentuated is that when it's open to vote to update the MAC, public health officials are weighed 2 to 1. For example, your vote as a EHA official or EH official counts twice as much as what mine does as someone in the management sector or someone in the private sector. So again, it's that emphasis of this is public health. This is what the MAC is really trying to do, right? It's not trying to sell a product or a concept. It is trying to keep people safe and keep people healthy. The MAC is also free. There is no need to purchase the code. You can download the MAC from either cmac.org from our website or from cdc.gov/MAC. And you can also see additional resources CDC's made available at their particular website. So yeah, it's free, right? Again, we're emphasizing, the protective of public health. We don't want any barriers to this, right? You may see some in the future where maybe there's printed versions for sale, but the code itself is a free download. So that's another aspect, right? And again, I've mentioned this over and over again. It's everything. It's all encompassing rather. It covers all aspects of the venue, from the design phase all the way to breaking ground, all the way to the radius of the wall, all the way to lighting and ventilation, chemistry, operations, staffing, etc. And again, just reiterating, the MAC always looks for science first, and then best practices where science is lacking. So really is unique. I've had the opportunity to be involved in the MAC from its inception. I was on the first edition on a technical committee. I was on the third edition on the technical review committee. And of course, now in my role, I'm providing support to the MAC across the country in various very interesting and rewarding aspects, right? So definitely is an very interesting and wonderful document. So what's the history of the MAC, right? So when we talk about how this was developed, there was a workshop held in 2005, actually, recreational water illness prevention and disinfected swimming venues. This was held in Atlanta at CDC. And this is where the idea of the MAC as a need came into play. Swimming pool codes in 2005 were not that thorough, right? You had some codes out there through ICC. You had some of the ANSI codes, right? But we didn't have anything that was comprehensive. We didn't have anything that was public health focused solely. And there was nothing really that addressed operations beyond what was being done at the state or local and county AHJ level. A steering committee was formed of experts from across the country, including public health, obviously, to oversee the work from 13 different modules. And these modules were eventually harmonized into the various chapters and aspects of the MAC. We had over 140 aquatics professionals, and I say aquatics, but also health officials, right? 140 that worked on the MAC for 7 years to create the first edition. So this was a heavy lift and a ton of work. And a vast majority of these, except for a handful at CDC, they were all volunteers. They were not paid to work on the MAC. We had 2 comment sections, our periods from the MAC first edition, where 4,500 comments were addressed to ultimately come into this first edition, which was released in 2014. Just as a side note, we've just missed the release date for the 4th edition. We do anticipate that coming out either end of December, 1st of January, as it goes through 508 ADA compliance. But yeah, this was a huge thing. And even now, right, we see, we counted it up the other day, and we've had 140, 300, we've had about 300 to 350 professionals that have volunteered to work on the MAC through the various update committees, the various technical support committees, the various ad hoc committees to create this thing called the code and the annex that has been updated and kept extremely relevant. Okay. So again, it's a model, right? It was based as a concept off the model food code. So it is intended as a model. It is not mandatory, and it doesn't kick in until an AHJ or entity decides to adopt it and use it. It is commonly referred to in litigation and by aquatics management. My background is aquatics management and pool operations, and I can tell you we've been talking about the MAC since the beginning for a very long time, and is definitely influential in all aspects, from pool operator programs to builders to lawyers to safety programs and training programs. But we do see that reference, but it's not really enforceable until it's adopted by an AHJ at the state, local level, territorial level, or even as a federal entity. For example, the National Park Service has adopted the MAC for use in its facilities and its pools. The MAC's also flexible. It was intended from the very beginning to have flexibility in mind for our health officials, right? So what does this mean? You can adopt the MAC in whole to either to create a new code for your jurisdictions or to replace existing codes, right? You can adopt it in part. Texas did this to a rough degree in that they looked heavily at the operations and policy section of the MAC when they did a recent update to their code in 21. So you can adopt it in whole, you can adopt it in part, you can use it as inspiration to update your code. There's a lot of different ways you can use it, right? And honestly, that's what makes tracking the MAC so difficult, because we don't really know how everyone's using it. We're learning more day in, day out, but the variety of use is what makes accurate tracking very hard to do. Because we just don't know, right? We don't know how Illinois may be looking at the MAC specifically, right? Because we're not down in the trenches. We're not having these conversations with folks as yourselves every day. So yeah, but the intent is 100% flexibility in how it's used. From a CDC standpoint, the CDC calls it a win if the MAC is used at all. Whether it's adopted, whether it's just referenced, that doesn't matter. It's meeting its goal, right, of influencing and being protective of public health, even if it's just used by reference. So it's another way that the MAC is unique from other codes and other standards. Okay. So again, when we look at the scope, just to reiterate, is only intended for public aquatic venues. It is not intended for residential, nor will it ever dive into residential. Pardon the pun. It's also not intended for natural waters, for lakes, for rivers. There are other aspects, other codes that would be more applicable there and other standards. It is only intended for man-made recreational venues, aquatic venues. So your water parks, your parks and rec pools, your Ys, hotels, HOAs, right? Anywhere where you have an artificial construction with a shell, recirculation system, et cetera. Okay? So very, very wide in scope and its applicability. The other thing about the MAC too is it also addresses novel facilities, right? And unique facilities such as splash pads and then flotation tanks. And then for the 5th edition, we're going to look at having guidance for surf venues and artificial swimming lagoons integrated into the MAC. So how is this thing called the MAC updated? As I mentioned, there's an every 3-year cycle. We are a little bit off because of COVID. So that threw everything off, like it's thrown off the entire world, it seems. But we're going to start the next update process next year. And this starts with the submission of a change request. And as I mentioned, anyone can submit a change request, period. If there's something about the MAC that you're not happy with, that you think needs to be changed, modified, deleted, included, you have the ability to submit a change request, period. All right, there is no need to be a member. There is no cost. You don't have to be affiliated. You're a stakeholder because you're a human being in the United States that has some dealings with recreational water. All right, that means you can submit a change request. CMAQ manages the update process. So we'll collect, assess, and relay this input for CDC for consideration. We have 2 different groups of committees. We have our technical review committee, our TRC, that's formed within CMAQ. This will consist of 6 public health officials, 6 individuals from across the aquatic sector, and 2 to 3 members from academia. We do shoot for 50% public health, so these numbers might change slightly as we look at our constituency for the TRC. And the TRC, their job is to evaluate each change request. So it doesn't matter how crazy it is, right? So I'm just looking at names on my screen, right? I'll use Craig, and Craig talked earlier. Craig may issue a change or submit a change request to change the minimum chlorine level from 1 part per million to 20. He may believe that's a step in the right direction, right? The TRC will not dismiss it no matter how wild it is. If it passes muster on the style guide to make sure it's written appropriately and to make sure there's good scientific backing and it's a complete CR, right? Meaning there's no gaps, there's no multiple changes, right? Meaning that there's a justification written, then it gets reviewed, period. So we don't turn any CR away just at face value based on, hey, we think this is not a good CR. Whether we agree with it or not, everything gets reviewed, everything gets discussed. So the TRC does their chart of work, and then to help the TRC, we have the technical support committees that are formed. These are 3-person to 5-person committees that are topical. So for example, operations and maintenance, right? Lifeguard and bather supervision, and they lend their technical expertise to CRs respective to their areas. And sometimes we see CRs that may apply to multiple technical support committees, but they will review these and provide feedback to the TRC in the form of a written opinion on that particular change request. And then in deliberations by the TRC, that TSC opinion, if applicable, will be considered. After the change request submission window is closed, then the CRs are open for public comment. All public comments are reviewed by the TRC, and they're considered when reviewing or considering that change request. So, and again, anybody can comment on a CR. Obviously, if you have an offensive comment, we'll remove that. But apart from breaking social constructs and being human and being a polite human being, all these comments get reviewed. And again, the TRC factors that into its deliberations. So these the first public comment period is intended to help navigate, or that's a bad word for it, to help influence the TRC deliberation. After the TRC has completed its review of CRs and has issued a voting recommendation for each CR, then a second comment period is open. Now, this second comment period is not intended to monitor to influence the TRC because that's been done. This second comment period is intended to influence voting membership, period. It will not be used to modify CRs. It will not be used for any changes. It's solely intended to influence the votes. And let me back up for a second, right? So how would these comments be used by the Technical Review Committee on the first comment period? The Technical Review Committee may go back to the CR submitter and say, hey, we've had these comments come in on your CR. These are our deliberations. Are you willing to modify your CR? It's optional. It's not mandatory. But we may go back, the TRC may go back to that submitter and try to modify that change request, right, as appropriate with that submitter's permission. If the submitter is not on board with it, then that CR will progress forward as originally written. After we close the second comment period, then CMAQ holds the vote on the code conference. So this vote on the code conference, this is where select change requests are presented. We don't always submit on every change request. We'll select which ones we feel have the most gravitas on presentations. For example, cyanuric acid, right? Anything related to cyanuric acid or disinfection, that would be a CR that's being presented. If a CR submitted to make a small change like barrier versus enclosure, that may not be submitted, right? We'll evaluate those and list those up for discussion during the conference. And then also at the conference, this is where caucusing takes place. So our membership would be broken down by sector. So public health officials would be a sector, and they would deliberate among themselves and caucus to identify how they should vote as a block. And again, this doesn't mean that Craig has to vote the way that all the public health officials do, but it's simply that that lobbying, that discussion to where you may see a recommendation of how public health should vote. And that's done internally, right? We're not really actively managing that other than providing a space. That is solely to where those individuals in that sector can come to their own conclusions, their own discussions, and lobby each other. All we do is we provide that space. That's it. Now, depending on what comments are received by or through the vote on the code conference, a submitter may want to modify their change request. And this is only from submitters, right? So after that, they may modify their change request based on these comments and this caucusing. And if so, any modified submissions are reevaluated by the Technical Review Committee. So we have multiple aspects where CRs are deliberated, discussed, and various recommendations shared, opinions shared, thoughts shared, right? So these things really get a lot of discussion on what they are and how they may impact the MAC and how they may impact public health. Okay. After we complete the conference and after change requests have been reviewed, any modified submissions, then there's a 30-day window open for voting. Now, only CMAQ members can vote on the changes. Anyone can submit, but you have to be a member to vote. And then CMAQ membership can vote to accept or decline each change request, right? Once, and I need to add a little slide in here, a little piece in this slide. Once voting membership once membership has made their opinion known, then the CMAQ Board of Directors will vote to ratify those change requests. So here's where I want to take a pause point, right? There are safety nets. There's safety nets upon safety nets. The first safety net to make sure we don't have 20 part per million minimum chlorine is going to be the Technical Review Committee. A safety net to make sure the Technical Review Committee hasn't gone off the rails rather, is the vote on the code conference and the caucusing. The third safety net is membership. hey, the technical review committee said that Craig's CR to have 20 part per million is a really good idea. Membership may say, wait a minute, that's a really bad idea. Okay. And of course, public health, they're weighted 2-to-1. Okay. Now, let's say this 20 part per million minimum chlorine level gets through the TRC, caucusing, and the vote, then it goes to the board of directors. The board of directors is another safety net, right? Because the board has to ratify all the votes. So occasionally, and it's not many, we had, I think, 9 change requests for this last go round for the 4th edition, where the board of directors recommendations differed from the voting membership. And typically, they're in areas where there's a conflict. So to give you a pertinent example, for the 4th edition, there was a change request that allowed computational fluid dynamics to be used for recirculating systems, right? For main drains, right? From that pool, but not from perimeter overflow systems. So that created a conflict, right? The rationale wasn't clear why that should be separated. So the board of directors voted to pass that second CR to allow computational fluid dynamics to be used on both main drain systems and perimeter overflow systems. So that's largely where we see the board of directors having that differing vote, right? To act as a safety mechanism, to make sure there's no conflicting information, make sure there's no really crazy stuff that gets out, that gets put in the MAC. So once all that happens, now it goes to CDC, right? And we have to say that CDC owns the product, right? CDC can make whatever changes they want to the code and the annex. CDC can agree with or disagree with or incorporate change requests however they want to. This is just a mechanism to make recommendations to CDC, right? So the CDC does reserve the right to deny any CR if it's not in the best interest of public health, or maybe the science is lacking, or the rationale as a best practice is not strong, okay? And this is very purposeful to make sure that the MAC always considers public health first, and that there are no outside interest, conflicts of interest, or industry interests, i.e. this product, that product, that are making their way into the MAC, okay? So once it gets to CDC, then there are 6 different centers that review it, including emerging zoonotic and infectious diseases, the National Center for Environmental Health, National Center for Injury Prevention. Those are just 3, there's 6 in total, before it goes on to legal counsel. And the MAC has to pass muster through all of these different centers. And then once it gets through the centers, then it goes to 508 compliance for ADA access, and then it's posted and officially released on cmac.org, but mainly cdc.gov/MAC. And when the CDC releases a MAC edition, they'll release not only the code in a downloadable PDF format, but they'll also release a description of rationale on why CRs were accepted or not accepted. And they'll also release a modifiable Word version. So lots of different options there to use. It's really, it's a cool process. It sounds cumbersome, and it is, because it's a slowdown, right? It's a purposeful slowdown, purposeful review, multiple levels to make sure that public health is always put first. So what are some key things about when we talk about this update process? One is transparency. We strive to be as transparent as possible. And in our continuing internal review, if we see areas where transparency is lacking, we try to build those. A great example is, this is recent. You're the first to hear about this. This was just decided in our board of directors meeting yesterday. But believe it or not, we really didn't have a lot of guidance on how to select our chairs, our chair and vice chair for the TRC. So that was an issue we had, because we want the strongest possible systems. We want the highest level of confidence in the product, in the code, and in the work that we do. So from this point forward, there will be applications specifically for the TRC chair and vice chair. And then the board of directors will select who the chair and vice chair is. So the big thing this does is this keeps me, right, or any of one of us at CMAC from cherry picking who we want to be on there, right? This keeps me from having my friend Bill being the chair of the TRC, because I think Bill is going to vote the way I think, right? So this really helps add more validity to the process. But in addition to that, anyone can listen in on TRC deliberations. All are made open to the public. There's a call-in line which you can call and listen to deliberations. Typically, these have been Zoom calls since the pandemic. We also post meeting minutes and try to really have everything up there, including summaries on CR discussions. So we try to have multiple points where we are as transparent and open in our entire process. And of course, input, right? So we always look for input for public health and aquatic sector representatives into this process. It's not just a room full of 5 people. And then each CR gets evaluated, as I mentioned. So what does this mean? In 2020, we had 530 change requests, ranging from simple word changes or a definition change up to rewrite of sections. So it can be a lot of work. And of course, anybody can submit a CR. And here's the big thing, right? The MAC does not exist to upend the industry. This is not the Virginia Graham Baker Act, right? We're not trying to cause, or the MAC isn't trying to cause ripples and chaos throughout the entire sector. One of the overarching principles of the MAC is evolution, not revolution. We try to inch things forward in the interest of public health, because we do have to balance reality. So there are some things that are really good ideas that we do need to implement now. For example, UV on splash pads. We have really good data that shows that UV needs to be on splash pads, right? We have lots of illnesses. We have lots of outbreak data we can look at that indicates UV needs to be on splash pads. So that's an area that we can certainly incorporate based on science. There are other areas where the science is strong, but not strong enough to justify a total revolution. So in that case, the MAC will incrementally make changes, right, to further advance the code, further advance public health, and not upend the country. So, and the other thing that we have to factor in is cost, right? So we do look at cost and being an undue burden, especially when the data impact, or the impact of public health, right, of this decision on health of swimmers across the country isn't really that strong, right? So, again, evolution versus revolution. We're not trying to upend the industry. We're not trying to be a chaos agent. The MAC exists to move this concept of public health and safe swimming along in a controlled manner, not an absolute bonkers, upending, destroying the industry manner. So when we look at the MAC sections, right, we see 4 different sections here. There's actually 6 in total. There'll be 7 for the fourth edition of the MAC. The first 3 sections are user, right? So you have your preface, you have your user guide, you have your definitions. Those are sections 1. Section 4 covers facility design standards and construction. This is your build, this is your radius, lighting, making sure that we have automated controllers, right? This is everything to build. Section 5 is facility operation and maintenance. This is your coring level, right? This is what equipment you need to have on hand, right? This is how often things should be tested. And section 6 is policies and management. So this gets to be a little interesting in section 6. There are a couple of subsections that deal specifically with training courses. Pool operator training courses for qualified operators, qualified lifeguard training courses, qualified lifeguard supervisor training courses, where it's standardizing the content in these courses that we're selling entities that you need to comply here, right? And then, so once we get into section 3 of section 6.3 rather, then we start talking about facility management, right? How do we run our lifeguards, right? What rotation should they have? What's the maximum time they should have in the lifeguard stand providing active supervision? What are the standards, right, for them to meet? What does a safety plan look like? What are the components of a safety plan? In section 6, we also see the criteria for crypto disinfection, or rather, I should say RWI response for pools with and without cyanuric acid. We see information on how to respond to Naegleria flareii, not Naegleria flareii, but Legionnosis in spas, right? We see that in there as well. And then new for the 4th edition is chapter 7. Chapter 7, it will be all of our novel venues. So for example, flotation tanks, those were in chapter 4 as a subsection. Those now have been separated out into this novel venues to make things a little bit easier, more user-friendly. So here's just an example of language for the code. I'm not going to spend a whole lot of time. Y'all live in the code language world, but we see how the numbers are used, right? We see how the titles are used. Whenever you see kind of all caps, that's going to be a definition to refer to in the code. Okay. We see another example here from section 5. In this section, I wanted to point out because it refers to other sections in the MAC. Again, y'all are environmental health folks. You're used to dealing with codes. You're used to your state and local codes referring back to itself. So nothing new there. And then one thing to point out in policies and management, right, just an example here, whenever you see the superscript A, that indicates an annex section, right? So for this particular entry, there's an annex section that discusses why facilities should keep an operations manual, why they need to be in printed and e-formats, right? And what's the rationale that the committee that created this section, what were they thinking for this particular code section? Okay. And then here we see an annex example. And again, we see very, very big discussions. The annex, we might have a couple of paragraphs on some items. There are some items that are literally less than one paragraph, and there are others where there are literal pages. So depending on what the topic is, it could be a very lengthy explanation, or it could be just a couple of lines, right? But everything about the annex is intended to help you as a health official, you as an end user, understand what the mindset was, what the rationale was in that particular code section. Yep. And so we've already talked about the preface, user guide, and glossary. These are things that will help you in understanding the MAC. And of course, the user guide also dictates, or not say dictates, that's a bad word, but it indicates how shall, may not, and may should be used inside the code. Another resource available are mini MACs. So right now there are 4 mini MACs, preventing pool chemical injuries, preventing inline production of toxic chlorine gas, reducing the spread of crypto, and then swimmer hygiene and diaper changing. The purpose of a mini MAC is to have a smaller bite for relevant topics, right? One relevant topic. And then, so as a user, instead of having to sort through the entire code to find everything related to this, it's pulled out. So like with preventing pool chemical injuries, pardon me, I'm losing my style of speaking here lately. For preventing pool chemical injuries, that mini MAC will have everything you need, every reference in the MAC related to that topic. So it does make finding those topical items a little bit easier than having to navigate through the whole code. We are looking at additional mini MACs to be developed in the future. And so, for example, operations mini MAC, right? We may be looking at something like that. Splash pads mini MAC, we may be looking at something like that. So we are looking at what other mini MACs may be helpful to make the lives of our health officials specifically and end users a little bit easier in navigating this thing called the MAC. So who are we? Who's CMAC, right? So we're a leader in national, state, and local efforts, promotes public or safe and healthy swimming at public venues. We're member driven. That's important in that we're member driven for our support for our chart of work. We're member driven specifically in how the code is updated. So, you know, we're not flashy. We don't sell a product. We don't do anything cool per se, but we do really, really important work. Our primary goal, as I mentioned, is facilitate the MAC update process. That's the primary reason for our existence. A secondary reason is to provide industry support. So as you go through about your regular lives in dealing with pools and as an environmental health specialist or generalist, you know, keep my name and number, keep our email address, keep our website, right? We're there to help you. In fact, in part of our contract with CDC, one thing we have to do is provide technical support to the users, right? This is free. We do not charge from that. The only charge that may exist is if you opt to bring us in or want to bring us in for an on-site consult. There would be a charge with that. We have no idea what that is. That really hasn't happened a whole lot in our history. But apart from in-person on-site, everything we do for technical support is free. So this is helping folks with plan reviews. This is answering technical questions and technical content, and really just almost everything under the sun when it comes to operating and managing a public venue, aquatics venue, not only for health officials, but also for operators, builders, designers across the board. So we were established really to have this update process for the CDC, for the MAC, because it's a lot easier for an external group to manage this update process than it is inside the federal government. Initial funding was provided from the National Swimming Pool Foundation, Councilman Hunsaker, and SeaWorld. Those were the three entities that kind of helped kick this thing off. We're funded through CDC grants, through donations, and through your membership dollars. So in addition to updating the MAC, right, and providing technical support, we help facilitate research and education. So right now we have a research project that's ongoing to address indoor air quality. And there's really been some interesting stuff come out of that. And we have the beginnings of a very robust research agenda for the future. We've also facilitated some research into, at least a meta-analysis, into cyanuric acid use. I've already mentioned providing technical support. And another thing that we do is we actually will review and certify programs and products. And this is for you, right? This is for you as a health official. In your daily lives, whether you're a specialist or a generalist, you may not necessarily have the expertise, time, or resources to review a product to see if it's compliant with code. So that's one area where CMAC steps in, right? We'll take a product, we'll take a course, a training course, we'll compare it to the MAC, and then if it passes muster, we'll certify that product as being MAC compliant. So that means that you as an official, when you see that CMAC stamp on a product, you know that it complies with the MAC, you know that it's been thoroughly reviewed. So our review process varies. But for a training course, it usually takes 30 days. And typically most training courses come back having to make modifications. We've only had one or two that had 0 modifications for it. So typically it's a 30-day review period. And honestly, by the time they make or achieve CMAC certification, we're talking about 60 to 90 days on average. So it's extremely thorough in our review of these products. But again, this is for you, right? To where it makes your life a little bit easier. You can decide to take it at face value or have a little bit less of an impact or less of a review on your end. But we really did it to make the health official's life just a little bit easier, right? And honestly, that's another reason the MAC exists, is a lot of times you don't have the resources, you don't have the time to go back and research all of these items. And collect and discuss things with industry experts. So really the whole MAC is just a love letter to our health officials. As far as our team, this is our team. You have myself, obviously, as technical director. We have our executive director, Christy Reister, our communications director, Jill, and admin services, Susan. We're all here to help you in however we can in your efforts to help keep pools healthy and safe, and also in your efforts to look at and utilize the MAC in various ways. Yeah. And again, just a quick call for membership, right? Our tagline is driven by your expertise. Whether you're an aquatic sector individual or public health official, we need you not only to have your vote, right, but also to have your input on everything from the change request process, right, to deliberations, discussions, right. We have educational resources that are free for membership. For example, we have a webinar series, and our next webinar in December, which is free for CMAC members, is NSF. We're having NSF come in to discuss NSF 50 and 61. So really helpful stuff that gives you insight, right? And of course, you do have to be a member to serve on our various committees. And again, we've made a conscious effort to make sure that public health is represented on each committee that we have. So that means a lot of work to be done, and a lot of opportunities for health officials to have their voice heard and influence this thing called the MAC, and influence change request and influence guidance documents. So with that being said, I'm going to go ahead and close this out. And I'd like to open the floor for any discussions, any questions you may have, and just really have a good chat with y'all.
Did anyone here have questions for our speaker? No, I'm not. Oh, we do have a question. Okay.
Did you already compare and contrast the VGB with this model aquatic code?
Okay. He had asked, did you already compare and contrast the VGB with the aquatic code?
Yes, absolutely. Absolutely. So, and the way we handle codes and other codes and standards, right, is you do see references. So we do make references to ANSI. We do see references to other codes like OSHA or other entities like OSHA. In the case of VGB, not only did we include some aspect specific, but also primarily we just made a reference, right? So we're referencing the ANSI standard, the VGB itself on compliance. So not every time do we reinvent the wheel, so to speak, and rehash everything that's out there. For VGB, we simply made reference to those particular standards.
Any other question or a follow-up question?
Yeah, you referenced the National Swimming Pool Foundation funded this originally.
Correct.
But now they're no longer in existence, and you have this successor agency, I guess, or organization. That's the Pool and Spa Association. Can you touch on that a little bit? Because there's a bunch of us that have our pool inspector certificate from the National Swimming Pool Foundation, which does not have an expiration date. And the new organization says, if you get ours, it expires in 3 years. So what happened to all of us people in public health that have our certified pool inspector from the previous organization? And now it's, I believe it merged with the pool and spa. Just could you explain that a little bit?
Sure. So I only mentioned NSPF because they were a founding sponsor, right? They helped kick off this thing called CMAC and gave dollars to start the organization. So we always kind of historically reference that, right? So what happened a few years ago is you had a merger that occurred between the NSPF, National Swimming Pool Foundation, and the Association of Swimming Pool Professionals, something like that, ASPS. So this was a merger that occurred, and they formed what's now referred to as the Pool and Hot Tub Alliance, or PHTA. The PHTA is unaffiliated with CMAC and unaffiliated with the MAC. We are separate entities. They have supported us in funding on our research agenda. But apart from that, the entities are largely separate. We do have a harmonization committee that seeks to harmonize the standards through PHTA, the ISPSC through the ICC, and the MAC. But that's really kind of the limit of our relationship. So I can't really speak on what's going on with the CPI course through PHTA or any expiration dates. You would have to reach out to PHTA specifically on that. That is out of our control and out of our wheelhouse. I know that's not really something necessarily fun to hear, us kicking the can down like that, but we really don't have any input on that organization or their practices.
Just for your information, they did exactly that, which is kick the can. They just said, well, that's not possible that you didn't have an expiration date. Sent them a copy and, then they went mute.
Yeah.
They disappeared.
Yeah, and in just full honesty, that's our purview, right? When PHTA was formed, they absorbed everything from NSPF and APSP or ASPS. So it's in their right to get rid of stuff. It's in their right to change the terms, whether we agree with it or not. There was a little bit that went on with the CPO course that caused a little bit of chaos with instructors that had to be sorted out. Where they made some changes that weren't historically in line, and they had to make some corrections at the last minute. So I will say this, just because you brought up a pool inspector course, CMAC is working as we speak on developing a pool inspector for health officials course. It is health official centric. It is not necessarily intended for the industry. It's intended for public health officials. And we hope to launch a pilot course at Ieha in 23 for that. And then we'll do a final course release in early 24, first quarter 24. And it's going to be targeted for public health officials. It's going to be MAC focused. It's going to be public health focused. And we have significant public health input into the development of that course. So it's kind of one of those written by y'all for y'all type things. So just kind of keep that in mind as you move forward. That may be something you're interested in.
All right. Any other questions from the audience or via Zoom? I don't see anything else. So Dewey, I just want to say thank you. Thank you so much for joining us today. And if I don't think there's anything else, then I think we're good to go to kind of move on to our next person. Once again, thank you so much, Dewey. It's greatly appreciated.
Thank you. And I just want to give an apology very quickly because I've been calling you Amy. And you are not
okay.
Amy. I just realized that. So
it's okay. It's okay. I don't put a lot of stock into it. People now pronounce my name wrong all the time.
I have a unique name, so I tend to be a little more sensitive to it.
No, I appreciate it. Thank you.
Well, I just want to thank y'all for allowing me to be here, and thank y'all for listening. And if there's anything I can do, if you have any questions, please feel free to reach out. And this is for all the audience, not just you or any other. Right. So I'm here for you, however I can help you.
Thank you so much. We greatly appreciate it.
Great. Thank you.
All righty then. So for our last session for today, last but not least, we have Judy, who's joining us from AIB International, here to talk to us about root cause analysis. And Judy, I do believe I saw you online, so feel free to go ahead and get us started. And yeah,
Well, good afternoon, everybody. I'm going to share my screen, and this is the hardest part. If we can get this to work, it's always a good day.
yes.
Can you see my
yes,
screen?
yes, yes, we can.
See, once you can see the screen, like I said, it's always a good day, and it's nice to be here. And I really appreciate the opportunity to come and talk to you a little bit about the food industry. So I work for AIB International. I am a passionate food safety professional, absolutely passionate, but in the industry, well, I started really young. Let's just say that. But I've been with AIB 32 years. And like I said, I started really young. Keep that in mind. AIB International, if you don't know the organization, been around over 100 years. We're in 130 different countries, and we do food safety inspections and training and a lot of e-learning. And in fact, we just launched a brand new e-learning course called Food Safety and Sanitation, just an outstanding course. So at the end, I'll give you my contact information. And I would encourage you to reach out to me, and let's stay in touch, because we can teach each other a lot. I'm really very confident about that. So I was asked to speak about root cause analysis. And let me tell you why this is so important right now in the food industry. If you look at FDA findings, what they find when they do their inspections, and then you compare it to AIB inspections, and again, we are a huge organization, very global organization. And if you look at the data, it's almost the same. I mean, what we're finding is the same that FDA is finding in the food industry. And if you compared that data to, say, 5 years ago and 10 years ago, guess what? It's still virtually the same. The industry is not moving forward the way it needs to move forward. We're still repeating a lot of issues. And in fact, when we do AIB inspections, we'll even note if it's a repeat finding, because there's so many repeat findings. What we've really decided and determined is the industry struggling with root cause analysis. And that's why I was asked to talk to you about it here today. And I think it's something that you can really, talk to the industry about, make sure they're not just doing corrections, make sure they're doing corrective action. They're not just fixing things, fix it once and done. We want to make sure they're fixing problems and systems to make sure they don't reoccur. So what is it? I mean, what really is root cause analysis? Well, there's a definition on the screen, but it really is making sure that you eliminate a problem. That's really what it is. And again, ASQ gives you some definitions, and you can read them on the screen. But I use this example. It's brainstorming, it's investigation. And then I use this example, the weed analogy. I always have dandelions in my front yard, and I pull them up and I chop them with the lawnmower, and I still have dandelions in my front yard. And you would all say to me, well, Judy, you're not getting to the root. I mean, you got to pull them up by the root or they keep coming back. That's how findings are in the industry. And that's why we see the same findings over and over and over. How many times are we going to write up a facility because their doors are not tightly sealed? How many times are we going to write up a facility because the employees are not washing their hands, so on and so forth? So that's what root cause analysis really is. It's getting to the heart of the problem. And why do we do it? Well, we want to reduce the likelihood of injury, illness, or death, reduce recalls, reduce customer complaints, and certainly eliminate audit non-conformances, and prevent the what I call the re's, the rework, the reclean, the reprocess, the reject, the repack. So really, it's getting to the heart of the problem. So again, let me give you a real life scenario, So my dandelions, of course, that's a true scenario too. I do just chop them up with my mower, I admit. But this is interesting. This is the Lincoln Memorial, and the stone exterior was deteriorating. And what we did, is we just treated the symptoms. We would replace the deteriorated stone and paint over it. Deteriorated stone, replace, paint. Deteriorated stone, replace, paint. Then we started doing this exercise called 5 why. Why? If you just keep asking that, you don't have to ask it 5 times. You can ask it 6, 7, 9, 4. Till you get to the ultimate answer. So in this case, we did the 5 whys. Why is the stone deteriorating? Well, because we're using high-powered sprayers every 2 weeks. Why? Why are we using high-powered sprayers every 2 weeks? Well, we're removing bird droppings. So our first solution is let's experiment with netting. Like let's get rid of the birds. We stopped the 5 whys a little too early. We spend a fortune. We go out. We put netting up. We're trying to provide a solution. But if we keep going, we say why? Why are there so many birds? Well, they're feeding on spiders. Okay, you keep going. Why are they so many spiders? Because they're feeding on the lesser insects, right? Spiders feed on lesser insects. Why are there so many insects? Because it's the first building in the area to have the lights turned on each evening. So the problem was the stone exterior was deteriorating, and the true solution to this problem was to turn on the lights 30 minutes later than the other buildings in the area. And this is a true scenario. And it was very effective. And then they, the folks in Washington got even smarter and started to put the lights off of the building and put them away from the building so the insects would go away from the building and so on and so forth. But when you originally hear the problem, you say, well, the deteriorated building, you start reacting. You want a solution. You want to fix it fast. Root cause analysis is not always about fixing it fast. It's about fixing it right. And what you do is there's two things. And when we do this, we only have a short amount of time together. And we actually teach this as a full one-day course. So you can see we're going to do very high level here today because sadly, I don't have a whole day to spend with you today. And you are saying, I don't want to spend a whole day with this person either. So we only have a short amount of time. So we're going to get through this fairly quickly and open it up for plenty of discussion. But the 5 whys, as I mentioned, is you go through the exercise and you ask yourself the why over and over and over again. Why is this happening? But why did that happen? Because of this. Well, why did that happen? And when you do that, you'll ultimately come to a conclusion. That conclusion is what you want to look at as this is the root. This is the real problem right here. This is the solution to the real problem. To the right on the screen, you see a fishbone diagram. And a fishbone diagram, we're going to speak a little bit about it, but to do a fishbone diagram, they call it that because it looks like a fish. You really have to understand 5 why. So again, 5 whys, it's not fixed at 5. Everybody thinks, well, what if I only get to 4? 4 is fine. What if I get to 7? 7 is fine. It's the intent. That's what you're trying to do. But what you're ultimately trying to do is push beyond superficial solutions. You're trying to really get to the heart of the problem. You're trying to challenge yourself. And that's why, is it fast? Not always, especially if you do it right. And when you really want to do it right, you do it with a team. You get individuals together and you actually go through the exercise as a team and you say, why? Now, here's just a little twist for you. With the scenario that I gave you with the Lincoln Memorial, you know who ultimately solved that problem, who came forward and said, I can help with this, was actually the person that was washing the building in the first place. So that's why it's important that you bring different disciplines to your meeting to try and understand the whys. Here's another one. The problem, there's an unprotected bulb in a product zone. We all know that glass has to be protected in product zones. Product zone is the area that the food is contacting and the area directly above the food. That's how we describe the product zone. You might call it a zone 1, for example, but there's an unprotected bulb in that area. And if you immediately say, well, it was because installed by maintenance. And what do? We yell at the maintenance people. We write a work order. We get mad. It was because it was installed by maintenance. But if you go through the 5 whys, why did maintenance install it? Why were there unprotected bulbs? Truly go through that exercise. If you look at the bottom right, it says it's not part of the receiving procedure. That is ultimately the root cause. So if you follow this, and again, I'll leave the slide deck with you and you'll be able to read through each and every line. We just can't do it for the sake of time. But you will find out what you originally think is the problem, like, oh, it's maintenance. Let's be mad at maintenance for the day. It really ends up being something completely different. And that's why what we originally solved was we thought it was a maintenance issue. So we thought we fixed it. We retrained people. We did whatever, thought we solved the problem. And that's why it reoccurs, because we haven't really solved the problem till you go through the exercise. And then you find out, wait a minute, it has nothing to do with maintenance. It has to do with the receiving procedure. Once you get the hang of the 5 whys, then you can practice with this. This is, again, the fishbone diagram. The problem that you're trying to solve is ultimately in the circle or the head of the fish. And then what you do is you populate these lines, and I've populated it for you. This is what's typically used in the food industry. Equipment, process, people. You can see underneath what typically flows with that, equipment, production equipment, measurement tools, computers, process, cleaning procedures, HACCP or HARP-C, work instructions, people, line operators, technicians, sanitation, so forth. Materials, environment, and measurement. Materials, ingredients, packaging, the environment, time, location, and then measurement, temperature checks, weight checks, metal detectors, things like that. And what you do is you populate that, and then you give yourself the problem. And again, this would be in the circle, okay, or the head of the fish. A decomposed rodent was found in trap number 14. And remember, we're not saying a mouse was found in trap number 14. We're saying a decomposed rodent. And that's an issue because we've allowed a pest to decompose, which means we're not monitoring our rodent control devices as frequently as we should. And what happens when that decomposition occurs is we start attracting other pests. So certainly it's a big issue. So we have a decomposed rodent in trap number 14. And then we go to materials and we go through the 5 why exercise. And we go through and we say, okay, what did we find under materials? Well, there's obsolete packaging in the warehouse. What about the environment? Construction has begun on the empty field, for example. What about people? Contractors are working on the new x-ray and they're leaving doors open, et cetera, et cetera. So I think you get the hang of it. And what you're trying to do is do the 5 whys, and you'll ultimately come up with the same thing, a single answer. Now, sounds really simple, right? You go, oh, that's not hard. I can certainly do 5 whys. I can get a team together. I can encourage my sites that I inspect to do the same thing. And again, you can use the slide deck and use it for training if you'd like. But what are some of the pitfalls? What happens when it doesn't work? Well, some of the most common pitfalls are we see symptoms and not systems. Or we think of the cause as a singular, it's a one, an each. Or we find fault with people rather than the process. And the third one, finding fault with people rather than the process, is the one that we most commonly do. Our answer to everything tends to be, we'll do retraining. You know what? We'll retrain. And when you're doing your corrective actions, when you're looking at reports in your facilities and you're seeing corrective action, how many times are you reading? Well, we retrain, we retrain, we retrain. And that's why that's finding fault with people rather than the process. So again, here's an example of seeing a symptom and not a system. So we see drain fly activity in the production area. And the production, if we go left, just start on the left side, drain fly activity in the production area. It's because production left waste in the area at the end of the shift, expecting sanitation to remove it. Okay, that's the symptom. But if you go to that next level, it says responsibilities are not clearly identified. That's the system. Okay, you do the same thing with metal wear in a pump. Maintenance is supposed to reassemble equipment, but sanitation did it. That's a symptom. Responsibilities are not clearly identified. That's the system. And then the last one, unidentified items in a hold area. The symptom, production put the materials in the hold area and expected QA to mark them. The system, responsibilities are not clearly defined. And that's really important. So you're trying to not just see the symptom, you're trying to find the system. Thinking of the cause as singular. Here's one of the more common things that we see. A can of household insecticide is found in a maintenance shop. All right, or it's found somewhere it shouldn't be. Somebody brought in a can of spray from home because they have a fly problem. And then you start looking at all the causes. And is it because, again, a singular is somebody brought in a can of Raid, for example. But what's the real problem? The problem is there's flies somewhere that they're trying to control. Is it because of the standing water on the grounds? Is it because the damaged dumpster is leaking product? Is it because the air curtain on the doors are turned off, et cetera? And you can keep going through that. But what we're doing is we're going to treat the symptom. We're going to take that can of household insecticide and we're going to scold somebody for bringing it in. We're going to throw it in the trash and think it's never going to happen again. Have we really solved the problem? Nope. It's going to show up on the next inspection. It's going to be a different person that brings that household insecticide. Okay. And then again, the third most common one, finding fault with people rather than the system. And this tends to be, the most common thing that we see. Retraining is not a solution. Changing the training program might be a solution, but we always say, what did we do with that household insecticide? Well, we threw it away and we retrained the employee. It was Judy that did it, so we retrained Judy, forgetting that next week it'll be Kim, and the week after that it'll be Tommy, and so on and so forth, okay? Make it easy for employees to succeed. Make it hard for employees to fail. All right. And this is what you want to encourage when you go out and do your inspections. Give them suggestions. Make it easy for them to succeed. Make it hard for them to fail. Here's an example going left to right. The pedestrian door on the north side of the warehouse was open, allowing for pests ingress. Okay, so the door's ajar, pests are getting in. Food safety finding, training solution, retrain employees to keep the door closed. Did we solve the problem? Maybe. But what's the ultimate engineering solution? How about we install a self-closing device, a spring on the door? How about we make it easy for the employees to keep the door closed? And then the second example, materials rejected by the metal detector were inadvertently put back on the line by unauthorized personnel without evaluation. The training solution, we're going to train our employees to leave rejected material in, by the metal detector for the QA team. Even though it didn't work the first time, we're going to do it again. But what we really could do, because we want our people to succeed, is install a locked container to capture materials rejected by the metal detector and ensure only authorized personnel have access. So do you understand what you're trying to do is you're trying to make it easy for your employees to succeed and make it harder for them to fail. And you can do this every day in your role. You're the experts. And you can truly do this every single day in your role by giving them solutions. So the last thing that I want to talk about, and we're gonna open it up for some discussion, is a simple concept, and it's how we train our inspectors here at AIB. And we train them with a concept we call ICE: identify, control, and eliminate. It's nothing more than root cause analysis. It's the same thing. You find the problem, you've identified it. And this is what you do, right? This is your role. You go into a facility and you identify a problem and you control it. You give them a solution, a quick solution so they can fix it right away. But then you leave the facility and it's up to them to eliminate the problem. And this is where we can truly help as inspectors, is we can give them some more solutions on how they can truly eliminate the problem. So identify, control, eliminate. Identify, recognize the issue, communicate it's important, make sure everybody understands it's an issue. Correct it or control it, establish appropriate and timely control within the process to protect the product and product contact surface areas. And then of course the E is eliminate it completely. Now, everybody take a look at this, and you're gonna have to look at the screen, and I want you to be able to go off mic and tell me, how does this facility look for you? This is a warehouse, a food distribution warehouse. How does it look? Anybody wanna give me an opinion?
It looks organized, but I can see some gaps at the doors.
That's the right answer. It looks organized, but you can see some gaps at the doors. And that honestly is the right answer. And I bet if I asked everybody, everybody would say the same thing. It looks clean, but everybody would have the same thing, but everybody would say, but, because that's what we're trained to do, right? We're trained to see the beauty, but also recognize the opportunities, right? It's a nice looking facility. It's clean, it's organized. The floor even has a shine to it, but boy, we can all see the daylight just coming through that door. And that's what we would do. We would identify it, right? We would say there's daylight coming through the door number 5 and door number 6, and a little bit on door number 7. We've identified it. We control it. How do we typically control it? Well, we're probably going to go over and we're going to push on it and try and get it to close, or we're going to put brush seals on it. So I can tell you as an inspector, about 2 years ago, I had a door company call me, and they called me. They were out of Dallas, Texas, and they said, we would like AIB to come and speak to our door company. And I thought, well, that's a different request. I wonder where that request is coming from. So I asked them, I said, why would you want AIB, a food safety company, to come and talk to your door people? And he said, because, you are the best. We spend more money fixing doors when you're in town. And I thought, interesting. So with the truth of it is, what we do is we see daylight coming from a door like this, and our first instinct is, let's go buy brush seals. Let's go buy door seals. Let's brush seals. Let's go get that. In this particular instance, if you look up close, that's exactly what they would have done, is put on brush seals. But we interviewed enough employees at this facility, and we did some 5 whys. And what we found out was the door track was actually broken. We interviewed one of the forklift drivers, and he said, the problem is the door doesn't close because of a bent track. So he slides his forks underneath the door and then raises the door with his forks, and then uses the forks again of the forklift to push the door down. But if we had just done, without doing the 5Y, we would have just put brush seals on this door. And that's what we do with ice. We identify it, bad door seals, we control it, replace the door seal is the wrong thing to do in this case. And then we eliminate it by simply repairing the door track. So that's what you want to do, is go through the exercise of ice. So I've given you a lot of information in a very short amount of time. And what I want to do, a couple of things, is I want to open it up for just some general discussion, some questions. Tell me a little bit about what you do and how we can solve problems together. And I also want to share my contact information, because we're partners. And we have a new consolidated standard that comes out next year. And if you need a copy of it, I'll be happy to put it right in your mailbox. Just send me over an email. Visit our website. You can see some of the new courses, the e-learning we have out there, anything at all, or just reach out to me with questions. But again, we're partners. We're committed to exactly the same thing. And that's why if you have questions or suggestions, I'm all ears, and we truly want to help you however we can. What are your questions?
Okay, one more time. I had it muted.
Can you back up a couple slides to the dock?
Oh, someone was, oh, there we go. Thank you.
Back up a couple of slides to the dock. This one?
Yes.
Go forward one.
This one?
Go forward one more slide.
Go forward, right here.
There we go, right here.
So you look at it, the dock leveler is in the down position about an inch. So if you pull the door all the way down with a perfect brush, you still got a 1 inch gap that'll bring the dock leveler up. The other thing is, a lot of times, everything is in perfect condition. The door's open a foot because the guy in the forklift is too lazy to get off the forklift and push the door down.
But this is where we can provide solutions. And that's why, you know, and this is where I would encourage you to provide a solution. Use your experience and your education and your industry knowledge and educate that person. And sometimes it's not that they're too lazy. In the example I gave, for example, he could not get the door closed without pushing it with the forks because of the damage. So sometimes there's a reason that you just simply don't see unless you go through that 5Y exercise. But thank you for bringing that up.
Did anyone else have any other questions in the room here? No, I don't think so. Anybody on Zoom have questions for Judy? I'm trying to look and see. And I don't see any questions in the chat either, Judy.
Okay, well, thanks everybody so much, and keep up the great work.
No, thank you. Thank you so much for joining us. Most appreciated. Let's see. So I do think that concludes our virtual session for today. I really want to say thank you for everyone who has joined us. A special shout out to all of our guest speakers for today. This is not my main field within public health, so I learned quite a bit today. So I hope that you all did as well. And thank you guys so much. And I'll kind of keep this open in case anybody else has any other questions, but I am going to go ahead and stop our recording, and then I'll keep the kind of Zoom room open until 3:30. Thank you all so much.